You know yourself and how you learn best. This isn't a video of me just telling you how to learn. Instead, I want to point out some things that may help you get the most out of this course based on how this course is structured. Think of this course as having two courses into one. The first part, right over here, is the non-technical aspects of the interview. These are the skills that you will use throughout your career to get a leg up from the competition and make sure that you are able to optimize your chances of getting a well-paid job that you love. We're going to be talking about how to get more interviews and talk about all these topics right over here. We will also talk about non-technical interview questions, the most common questions that we get asked in an interview, and how to overcome them. And then finally, talk about offer and negotiation, an often overlooked skill, where we talk about how to handle offers and even negotiate a raise. The second part of the course is all technical. This is the really fun part of the course, where we learn fundamental computer science topics that get asked at some of the top companies. And don't let this diagram intimidate you. By the end of the course, you're going to master all these topics. We're going to learn about data structures like arrays, stacks, trees, graphs, and then specific ones like priority queues, binary search tree, doubly linked list. We're going to learn about algorithms, how to traverse a tree in a graph, how to use recursion properly, how to improve time complexity and big O notation, how do we do sorting, perhaps even searching, all with the goal to help us write better code and answer interview questions. One of my favorite sections here is when we're going to take you through a Google interview and demonstrate each piece of the puzzle so that by the end of it all, you're able to answer really difficult questions as if you were part of that interview. By the end of it, you're going to feel confident in any coding interview or whiteboard interview. At the end, we're also going to have a ton of questions for you to do on top of the ones that we're going to do together from all these companies, plus specific questions, whether you want to be a front-end engineer or a back-end engineer. So you have three options with this course. If you want, you can just do each course separately, and that is fine. However, the course is structured in a way that these two courses are ordered to make you understand the topic, build the fundamentals, and really connect the dots on interviewing. So to get the most out of this course, you should follow the lessons in order, since you may gain an insight or two, even if you thought, oh, leave me alone, Andre, I already know this stuff. So now that you have an idea of the outline, let's talk about what it means to succeed in this course. First, make sure you use our online Discord community to communicate with fellow students, ask questions, and talk about anything you may want when it comes to interviews. There's nothing better than talking out loud and practicing in front of people or with others. I'm also active every day on this community. The second part, these exercises get harder and harder in each section. They will challenge you and make you really extend your abilities as a developer. This is done on purpose. We're going to be building our foundation throughout the course and do challenging problems so that when it comes to real interviews, you find things easy. Although I walk you through the solutions, I encourage you to use available resources to solve the answer. Think of it this way. If someone offered you $10,000 bonus to study interview questions for a month, would you do it? That is what you're doing practicing for this. By working hard and practicing what most people don't do, interviewing, you're putting yourself in a higher salary position for the rest of your life. The third point, I know it sounds silly, but it's important. Anytime you feel like you're just watching a video and aren't understanding a topic, stop what you're doing and take a break. Come back to the problem. You won't be able to finish this course in 1 week. If you do it properly, it will take you about 1 month to finish everything in here, so take your time. This isn't a sprint, it's a marathon. Finally, try to complete the full course instead of just parts of it. Most lessons are tied into one from another, so that they flow and we keep building this pyramid of knowledge. We'll start from basic and get into more and more advanced topics. All right, I think it's time for us to start the course and get prepared to land our dream job. Let's get started and see you in the next section. Bye-bye. Hey there, this is Andre. You're about to dive into the course. But here's the truth. Most people won't finish this course. Why? It's because doing a course from the comfort of your home is going to take something away that is one of the most critical parts of doing anything challenging and worthwhile. Accountability. It's a lot harder to stop going to elementary school than to stop watching an online course, right? But here's the thing. There is a way to guarantee right now that you will finish the course and you will get through the ZTM courses no matter how hard they get. And trust me, it's going to get hard because we want to teach you really valuable skills. And they are valuable because they're hard to acquire. And this is why you're here. If you don't finish the course, it's a waste of your money. But if you finish the course, we truly believe it will get you the skills that you want. So this is what you're going to do that might put you outside your comfort zone, but it will be extremely effective in increasing your chances of success. Ready for it? You're going to come join our online classroom. In the next lecture, I'll provide a private link only for ZTM students. In there are 3 things I will ask you to do. 1 is to introduce yourself to the community. You can share as little or as much as you want about yourself. I'm going to finish X course by this date, and put that date in your calendar too. Number 2, go to Accountability Buddy's channel. Oh, that's a mouthful. And find someone who is starting a ZTM course right now at the same time. It doesn't have to be the same course, and you can have multiple partners. You're going to make sure that you each finish the course and the goals you set out to do. Finally, number 3, hang out in the general chat and talk about anything that you want. You will also have course-specific channels that you can chat in. You want to be surrounded by other learners like you to stay motivated and being part of a class. Now in here, we're also going to have virtual hangout sessions with myself, other ZTM instructors, and students. I recommend having the Discord server open as you go through the course and as you are learning. Now, I'm not saying this to sell you something. This is simply a fact of learning. When you learn in a group, when you surround yourself with other learners, when you have accountability, you are more likely to succeed. It's a fact. Finally, throughout the course, as you encounter problems or challenges, don't give up. Come back to our Discord server and ask questions and get help. But most importantly, as you start to learn and grow your skills, come here and help out other students. Teaching and helping others is one of the best ways to retain the information you just learned. If you create this routine around your learning, opening up Discord, start watching the lessons, surround yourself with others that have similar goals to you, you will have the accountability and the support system to finish the course. I promise you. Oh, and another fun bit, when you finish the course, you post your certificate in the alumni channel to become an alumni. And then who knows, the people that really are stars of the community become star mentors. Ooh. Now, this all may sound silly. You may say that you don't need anybody. But trust me, we've been doing this for many years, and there is this consistent trend of those that finish the course, get hired, and find success in their careers. You have to do the things that are uncomfortable sometimes to succeed. So that's it. See you in the next lecture and see you in our community. Hello! All right, I'm very excited. The very first section of the course. Now, in order to get any job, you need to have interviews. In order to get any interviews, you need to actually apply and get these interviews. If you're the best interviewer, the best at answering questions, solving puzzles, the best coder, it won't really mean much if you're unable to get an interview at a company and get them to see you. So the first step is also this, getting the actual interview. Now, the number one thing we need to do is to increase these odds, the odds of getting an interview. The more interviews you get, the more likely to get a job. the best way to get a job on top of being a good interviewer is getting in the door as much as possible and practicing your interviews. We are starting this course with this first step so that even just a few minutes into the course, you can start applying to jobs and practice your interviewing skills, as most companies won't get back to you right away. So while you go through the course, you can start applying to companies and wait to hear back from them. And while you're waiting, you can practice your actual interviewing skills. So by the time that the interview comes, you're going to be ready for it. So let's have this goal in mind. If I apply to 100 companies, how can I increase the number of companies that will get back to me with interviews? We want to increase this percentage. By the end of this section, I want your success rate to be higher than 1%. 5% maybe higher. It doesn't matter as long as we are able to increase this. By increasing your percentage, you're getting closer and closer to that dream job. If you're applying to 100 jobs and you're not hearing back from any of them, or you only get one interview, that's 1%. Then you're probably doing something wrong. So we're going to take a look at that and make sure that you're following best practice and you're also doing a couple of tricks to make sure that your success rate isn't necessarily 1%. However, there's some good news for you. Interviewing is a numbers game. A person who has failed 100 interviews and got rejected but got one acceptance at Google is just the same as a person that has never failed an interview and is now working at Google with you. Despite them having offers from all the other companies, never failing an interview, always acing their coding interviews. That doesn't really matter. At the end of the day, all you need is that one really good offer, and you're in the same boat as somebody else. How awesome is that? In your resume, you don't put down how many times you failed. Your resume looks the same as Einstein over there. Well, maybe that's a bit of an exaggeration, but I hope you get this point. Your resume looks the same as a person who never got rejected at an interview. That's the good news. And as a matter of fact, I know a person who has been rejected by Google multiple times, but kept applying and is now working at Google. So in the upcoming section, we're going to be talking about some of these topics. And it should not take you more than a week to set everything up and start applying to jobs. If you are spending more than that, then you're wasting your time when you can be doing something better, such as improving your actual skills as a programmer. Don't get me wrong, you can keep improving here and there to optimize things, but the overall effort you put in to set things up before you start applying should be less than a week. Most people spend too much time editing their resume and never applying to jobs, but we're not going to do that. So we're going to be covering how to optimize your resume, LinkedIn profiles, your portfolio, how to use email and referral to your advantage. And we're also going to cover some common questions such as how to make up for lack of experience. Maybe you've just recently learned how to program and you don't have any job experience. How do we overcome that? We're also going to talk about when should you start applying to jobs? When are you truly ready? Because some jobs post that they need 5 years of experience and you're not sure whether you should apply to them or not. And then finally, we're also going to talk about where to find the jobs and what are some of the best places to look for jobs and apply online. And last note here, I want to warn you. Some of these topics may be obvious to you. I've included them on here because not everyone will know these things. Although some things may seem obvious and silly, the last thing I want to do is to just assume that this comes easy and natural to you. Keep in mind that educational background, cultures, and many other factors will come into play here, so keep that in mind. The more technical, fun part, and frankly, my favorite parts, are going to start to begin after this section. So you're more than welcome to skip this section if you feel that getting an interview is not an issue for you. But otherwise, you might learn a thing or two. So stick with me, and I'll see you in the next video. Bye-bye. Everyone's favorite topic, the resume. I doubt that many people actually enjoy writing their resume, but unfortunately it is a required part of a job search. Well, actually in a later video, I'll argue that this is not the case, but for now, let's leave it at that. In order to maximize your chances of getting an interview, you will most likely need a resume. A brief document that someone will glance over it about 10 seconds and decide if you are worth talking to for a potential interview or phone interview. How can we increase the odds here? Now, resumes are a bane to everyone's existence. Nobody likes writing them. And no employer offers a job just because of somebody's resume. So you need to treat it accordingly. Resumes are simply a way to get interviews. And again, you'll see soon that it's not the only way. Spend very little amount of time on your resume, no longer than a day. Look at the types of jobs that you want to have and have the words and characteristics described in those job postings on your resume. Finally, make it personal for each position you apply to so that employers' names is on the resume. It will take you 10 seconds, but by doing just those things, it already puts you above most people that just send mass amount of resumes that look the same. Now, before we get into the details of how to make a resume look good, I want to show you a really nice tool. This is the resumemaker.online, a free tool that just creates a resume for you, or it gives you a nice design and a template that you can just fill out yourself. There are others like it online, so you shouldn't really format your own resume. I mean, you're a programmer, you're a developer, you should spend your time coding and use the skills that other people have in design to improve your resume. So unless you're a designer, you don't really need to focus on making your resume visually appealing, and you can just use a template like this one. Most of your time, like I said, is better spent on other things. And again, remember what I said. In most cases, resumes get viewed for only 10 seconds by a recruiter, and they'll decide quickly if they should contact you for an in-person interview or a phone interview. Most people spend too much time on the resumes, tweaking small things, changing fonts, and well, it's just a waste of time. Once you have a good resume that returns a good result, then you're all set and you shouldn't stress about it. And keep in mind that some companies that get a lot of resumes don't even have humans actually looking at the resume. And initially, they have some sort of an algorithm search that looks for keywords on your resume based on their job description. So let's go back to the slides. Now, I'm going to give you a cheat sheet in the next video and do a bit of an exercise that goes into a little bit more detail. But for now, let's follow these key points for having a nice resume. Resumes should be one page only. And unless you're an executive or something like that, you won't need more than a page. Second, make sure that your resume contains relevant skills. Each job has a specific requirement and they're looking for specific skills. These form great keywords to use in your resume. You can highlight the relevant skills in your professional summary that enables the employer to quickly get a grasp of the most impressive and important things in your profile. So again, try to use the keywords that they use in the job description in your resume. Thirdly, you want to make it look personal, like you didn't just mass email a bunch of companies. And one of the biggest mistakes you can make is to use the same resume for each job application. That doesn't mean making your resume handcrafted each time, spending hours for each company, because most of the time your resume will look the same. It's very easy to customize a resume though, maybe changing a headline or a summary section at the top where you can convey in a sentence how you would fit well with the company, or even just mention the particular company you're applying for. And then finally, you want to have some sort of an online link. You want to highlight perhaps your GitHub, your blog posts, portfolio websites. As a developer, you should have something that is present online for you to showcase to an employer. As a matter of fact, that is more impressive than a resume. And this is something we'll talk about later in this section. But that should be clearly highlighted on your resume. All right, these are just bullet points, and it's kind of hard to explain this without actually showing you a demo. So it's time for a little exercise. I have a little resume cheat sheet for you. And in the next video, I'm going to show you an example of a bad resume, then use the checklist to see how we can improve it. I'll see you in that one. Bye-bye. welcome back. It's time for a fun little exercise. Well, I mean, resumes are never fun, but I'm going to try and make this fun. I might succeed, might not. Let's have a look. Okay, before we get started, I have a resume cheat sheet for you that we're going to go through. And this is what you can do. I've simplified everything so that you do these items and you're already above average with your resume, and you're going to see some increase in the number of interviews you're going to get. But before we get into that, I want to show you, again, this website that we already talked about, the resumemaker.online. Now, I like this website because it shows you what part the interviewer actually cares about, or the recruiter actually cares about. If you look over here, we see the title, we see professional experience, maybe a bit of education, and then the left-hand side. I don't think you need birth date or nationality, but you get the idea. A recruiter usually only checks out the main points. And from there, if they're interested in you, they'll read further. But you want to focus on these main points where a recruiter's eyes are going to be drawn, so that right away, within the first second, they see that you're a qualified candidate. So keeping that in mind, let's go over the points. All right, so I have the cheat sheet here, and I have here a demo resume that I just randomly found online. Now, before we get started here, let me make this a little bit bigger so you can see. You can pause the video here and have a look at this resume and see how you might want to improve it. Or you can even bring up your own resume so that as we go along with each point, you can critique your resume. All right, so pause the video. Otherwise, I'm going to get started. Now, this resume cheat sheet, the first item on it is, does it use a pre-designed resume template? And if we take a look at this resume, well, I mean, it looks like somebody just wrote it in Microsoft Word with the most basic font, and it doesn't look very pretty. Right away, if I'm a recruiter looking at this, I'm not going to be impressed, and I'm going to associate low skills with the person that doesn't have a well-designed resume. So again, you might want to use a tool like the one I showed you that has pre-designed templates so everything looks good and professional. So we can fix that resume that way. Nice and easy fix. What about the next one? Make the resume fit on one page. I've said this numerous times, and you know what? This person has the resume on one page. That's a nice, easy one. Good job. What about the next one? Include words from job description. If I go into this resume, I don't know what this person was applying to, but again, the very first items, which is what a recruiter is going to look at, is going to read, I wish to obtain a web graphic design position where my unique technical and creative experience will be valuable. Having worked in media, I am familiar with a fast-paced environment, keeping tight deadlines, and maybe some technical knowledge and work experience. But just by reading this resume, I have no idea what this person is applying to. I just see that, well, they're looking for a web graphic design position, but it's not very specific. We want to include words from the actual job description. If they're looking for a front-end developer, make sure that the front-end developer, maybe JavaScript, is included in your objectives or technical knowledge right at the beginning. Again, keywords are those words that people are going to see, recruiters are going to see, or even machines that are reading your resume are going to see and say, ooh, this person is the type of candidate that we want. Let's look at the next one. Include company name you're applying to. This is so simple to do, and right away puts you above most resumes. You see over here that this person hasn't really included that. Ideally, you add it into the objective or maybe summary or the title, the company name or something specific to that company that you want to improve. Maybe the company is looking for engineers who can improve their infrastructure. Well, you should definitely have those words and that phrase in your objective. All right, off to the next one. Does your first item on your resume reflect what you are looking for or what they are looking for, the company is looking for? Again, this kind of goes hand in hand with the job description and the company name, but your technical knowledge, your objective, your experience should be exactly, especially the very first items, should be exactly what they're looking for. Again, if you don't include those words and you give them something random, like this person has a company name here and a company link of somewhere that they've worked in the past, well, I don't really care. And if I look over here, the first item that I see is HTML. If they're applying for a web graphic design position, HTML is probably not the most important item here. So again, I don't really care about that. All right, off to the next point. We're flying through this. It's not that bad, is it? Experience titles demonstrate value. Probably the most poorly worded sentence I have come up with. But let me explain what it means. The experience title should demonstrate value. That is, the work experience, which is usually the main part of the resume, should show that you provide value. If I go into this person's resume, the first sentence I'm going to read is that a company's name that they've worked at that I've never heard of, WebMD, which is a big website, so I've heard of them. And then I see web producer. And then again, responsibility includes updating HTML content. Doesn't really demonstrate a lot of value here. Instead, you want to make sure that your work experience shows a value. That is, instead of having the company name here, unless it's a big company like Amazon, Netflix, or Alibaba, something with a lot of good recognition, I don't really care about the company. I care about what you did. Web producer, that sounds a lot more impressive than this company name, so this should be bolded and highlighted. Production coder, again, more important than WebMD. Art director, again, more important. So you want to make sure that that's highlighted, that those are the key things that shows you're valuable. Another thing is, if you look at this sentence over here, this HTML part doesn't sound impressive. But the second part, cropping, retouching, optimizing photos for creation of thumbnails and other images, I mean, you could reword that and make that sound better, such as improving performance of the website by optimizing assets, such as photos. Having those first items demonstrate value is very, very important. And this is actually over here as well. When we go to technical knowledge, we see that the second item is MS Office, Microsoft Office. I mean, everybody knows how to use Word. It's not very impressive. Maybe adding Adobe Creative Suite, Photoshop, Illustrator, Flash at the beginning, if you're applying for a web design graphic position, is more important than Microsoft Office. And again, even this sentence, I've been hand coding HTML for 9 years, CSS for 4 years, Webmaster, done PHP, MySQL. Why is that so small and underneath everything? A recruiter is going to see this without reading this full sentence. That's probably the most valuable part of the resume. This should probably be up over here. Again, making those key items. Remember this image that I showed you, the very highlighted items, the most important thing. All right, I think I've talked about that point enough. Let's go to the next one. Do you have an online link? Again, if you're applying to be a web graphic designer, and for people taking this course, you're most likely some sort of an engineer, you should have some sort of an online link to your GitHub profile, maybe blog posts, maybe website portfolio. That needs to be at the very top. Next one, remove the word I. I wish to obtain, I am familiar, I was hired. I mean, all those sentences doesn't really tell me anything. You're adding extra weight. Again, you only have a few seconds to impress a recruiter, and you're adding these extra items that we don't really care about. As a recruiter, we want to know right away what you can offer us, what type of asset you would be. I have been. That we don't really care about that. Instead, let's just say something like professional web graphic designer with 5 years of experience. Gets to the point right away. Again, we don't care about I have been coding or any of those I's. Get to the point right away. Speak in the third person if you want to. Just make sure right away the first sentence that they read are the keywords and important items on the list. Let's look at the next one. No buzzwords describing how great you are. And you know what? This person definitely undersells themselves. I think this resume could be a lot better. This person definitely does not overinflate themselves. But what I mean by buzzwords is don't put garbage on your resume that doesn't mean anything. So words or phrases such as thought leader, passionate entrepreneur. And sometimes people actually think negatively on these type of terms. Don't tell the recruiter, him or her, what to think about you. And we want to focus on using something called action words. And that's actually the next point. Instead of using vague terms that don't really mean anything, we want action words. What did you do and what were the results? And you can be really creative here. Every time you do something with code, see how you add it to your resume as an action and an end result. It's very easy to just list your responsibilities, kind of like this person has done, but what did you actually do? And I mean, this sentence is actually pretty impressive over here. The content, or not this one over here, testing the content management system and seeing that migration to the new servers is running smoothly. I mean, that sounds a lot more impressive than coding HTML web pages. Action words perhaps should be testing, deploying, and observing content management systems to production servers. Maybe add some monitoring there, but you want to show exactly what you did and then perhaps even say what were the results, that the customer experience improved or that more customers came to the website because of this transition to production servers. And again, this translates into the next point. We want to measure everything in terms of impact. Don't just describe your responsibilities. We want to show off what we've actually done for a company like WebMD. Ideally, you have some sort of numbers, such as by how much did you improve the website performance by optimizing the photos and thumbnails? How much did the traffic of WebMD improve because of this migration to new servers? By having numbers, it's a lot more tangible. As a recruiter, I can see the impact that you had on the business. Because let's be honest here, companies hire people that are assets, that improve the company and create more revenue for them. So if you're able to demonstrate that in a past job, that you've actually, here are the numbers, this is how I improved the company, well, then you for sure are going to be a good hire. All right, let's talk about the next one. We're almost done here. Hang with me here. I know resume is not the funnest topic, but I promise you it's going to get better and better. So technical knowledge, skills should include what they are looking for. Only show years if it is impressive. So over here, this person, when I say years, I'm saying, hey, if you worked at this company only for a month or 2 months, well, that's not very impressive. But if you have a certain number of years of experience, this person has 9 years that they've been coding on HTML, CSS for 4 years. I mean, that's 9 years of experience. You don't even have to mention HTML or CSS. You can just say that you're a web and graphic designer with 9 years of experience. I mean, that sounds impressive. And you also want to make sure that these technical skills is what they're looking for. I doubt they're looking for MS Office or laptop PC hardware knowledge. They're probably looking for Photoshop, Illustrator, maybe CSS, maybe PHP, MySQL, maybe it's a React.js position you're applying for. You want to make sure that you show off those skills. And if you have many years of experience with them, make sure you include that number. If you don't have that many years of experience, just don't show the number. You don't need to tell them everything. All right, last 2 items. Include only items that are impressive. Experience, projects, education, technical skills. This just says, hey, only include items that a recruiter really cares about. For example, if I was an intern at a flower shop 5 years ago, as a recruiter, maybe recruiting for a software engineering role, I don't really care about your flower experience. I mean, hey, maybe some people do, but I doubt that they do. Only include things that are relevant or can be indirectly improve your odds of getting a job. You don't want to just fill out a resume just to fill out a resume if it doesn't actually add to your overall picture. Now, this person does a pretty good job. You can see that most of their experience is technical knowledge, so that's good. But we see over here that usually you want to include experience, maybe projects, education, and technical skills. Anything outside of that, I mean, you can add it, but only if you think it'll improve the way the recruiter sees you. But those 4 categories should be enough. And then finally, everybody knows this, but I added it on here just in case. No typos or bad grammar. If you're not a native English speaker or a native speaker of your language, make sure you get somebody to double check your resume that there's no typos, but everybody knows that. Whew. All right, that was a lot. I know, but hey, I'm excited just as you that we're pretty much done with the resume section. So we can get into the fun technical part. But, people have written books on the topic of how to write resumes, and there's so many things, so many minor things that you can adjust to make them important. But if you follow these steps, and I'm going to give you this sheet right after this lesson, you've pretty much done 90% of the work that is important for you to get a job. After that, you should be focusing on other things, such as improving your skills as a developer. So by just following this simple list, I guarantee your percentage of getting interviews is going to increase, at least with resumes. That's it. Hopefully by looking at this and your own resume and looking at these checkpoints, you can see how you can improve things. It's all about wording and how you can get the recruiter to see the top parts about you, the good things about you at the very beginning, so that it catches their eye and they say, I'm going to keep reading, or I'm going to give this person an interview so I can find out more. Now, that's enough for resumes. There are books written on the topic, but you have to remember that they're simply a way to get interviews. And as such, treat them that way. Don't overcomplicate them. But I hope you get the general goal here. Every word in a resume should convince the recruiter why they should hire you. I'll see you in the next video. Bye-bye. Let's quickly review what we know about resumes. Well, they should be 1 page. That's it. Don't cram everything into it. Make it clean and simple. Only include relevant positions and things that make you stand out. Make the resume be very clear into what you did, and don't use any vague language. I did this and it resulted in this. What you did, how you did it, and what were the results. Make it measurable. Personalize your resume. Instead of just emailing 100 companies, try focusing on a few companies and personalize that resume to them. And finally, make sure there's some sort of an online presence that they could check out in case they want to find out more about you. And at the end of the day, you have a few seconds to get the person looking at your interview to say, this person is smart and can help this company. Because remember, a resume is a piece of paper that someone will look at for a few seconds to decide to give you a phone interview or an in-person interview. So you don't want to spend a lot of time on it, but make it so it is effective. But it won't get you a job. You got to remember that. What will get you the job is your projects, your interviewing skills, things we're going to cover. Finally, be honest with your resume. Most companies will ask you questions about your resume and they can tell you if you made it up. It's better to be 100% honest and be able to know 100% about the projects that you worked on and the resume items, because that's something that you're going to talk about in the interview. I also want to show you a nice little tool. There are fun little tools like JobScan, where you can actually paste your resume, paste the job description, and you can scan it. And it will tell you how well your resume does. And it'll give you tips on how you can improve that resume to match the job that you want. But you may have noticed a problem with resumes. What if you don't really have that much experience or things to put down? What do you do in that case? What if I'm underqualified for a job? What if I've only been a developer for 6 months? What if I'm self-taught with no previous experience? What if I have nothing to put on my resume? We're going to tackle that question in the next video. I'll see you in that one. Bye-bye. What do I do if I don't have enough experience? What if I'm underqualified for a job? Well, first of all, You should have this mentality in mind when applying to jobs, and apply to jobs that you feel you are underqualified for. If a job is asking you to do something that you already feel confident, then you should ask yourself, what am I going to learn in this job? Am I going to learn actually? Is this job going to put things on my resume that will make me get better and get a better position in the future? Or am I just going to do the same thing that I already know what to do or how to do it? Finally, you have to keep in mind that job postings are put in order to weed out the weak candidates. I have seen way too many of these created by non-technical people or just making jobs sound tougher than it really is to remove junior developers or engineers from applying. So ask yourself, is this job going to be tough? Good. Then that is what you want. That's what you should be doing. Do you feel confident you are very qualified for this job? Okay, then maybe you should push yourself and apply to a job that's more difficult than you think. Every application should be a long shot. If you're applying to something that you're 100% qualified for, where is your room to grow? So dream big. But in order to dream big, you might have a bit of a roadblock. What if you don't have enough experience? See, I don't love resumes, and I don't think a lot of people do either. But sometimes without a resume, you cannot get an interview. And in order to have a good resume, you need to have something to put on it, like great experience. Here's the catch though. How can you have good experience if you're just getting started? It's like you have no hope if you're a beginner or if you don't have enough work experience because you're just out of school or you're changing careers. Well, not quite. As with everything, there's the regular way of doing things, then there's the smart way. You see, experience doesn't come just from working at another company. There are many ways that you can demonstrate experience without a past job. And here you'll find my favorite ways to show and prove you can get the job done. You won't have to do every single one of them, but 2 out of 4 of these, or even better, 3 out of 4, will be great at showcasing on your resume and make you stand out. So let's go in order and see how we can do this. The first one is GitHub. GitHub is a great way to demonstrate that you actually code, that you've built projects. The number one thing you can do is to start making commits and making sure that you have a good history of things that you've done. And by the way, if you're wondering how I got this cat picture in here, I'll show you a little trick in the next exercise to make your contribution look a little bit nicer and busier in case you're just getting started and you don't have a good past history. Another way to improve your GitHub profile or to just add more experience is contributing and participating in open source projects. For example, I've created a Zero to Mastery organization where we have a ton of open source projects by the community that you can contribute to. And they're made specifically for you to mess up, make mistakes. Nobody's going to yell at you. These are just fun projects that are open source that you can contribute to. And you can do as much or as little as you want, but this will improve your experience in contributing to open source projects, and it's something you can add to your resumes. Now, contributing to open source projects, recruiters love seeing this because this demonstrates that you can work with others and also with something like GitHub and version control. All right, let's look at the next one. The next one is website. If you're especially a full stack or a front-end developer or even a designer, you should have your own website where you can showcase your skills. This, again, is something you can speak about in your interview and about how you built the website, or it gives you a good way to talk about your past projects. Now, you're asking yourself, Andre, am I going to have to build a whole new website and waste a bunch of time? Well, not really. Let me show you a couple of tricks. You see, you don't need to build your own website from scratch. There's a ton of free templates like Creative Tim here that just gives you a nice template for you to use and fill in with your information. We can also look at this one, and again, free templates that you can use. I especially like the mountain template, and you can see that, you You can customize this to your own and make it look professional. And it's already designed nicely and also customized for different experiences, such as mobile, tablet. And in a day, you can have your own website. And just to show you how you shouldn't really spend too much time on your own website, one of my favorite people to follow is Kevin Kelly. He is very, very popular among the tech community, and he's just a overall really smart thinker. And you can see his website over here. It's very simple. Nothing exaggerated, very, very clean but small, very basic layout. And this is to show you that you don't need some crazy animations, make it all flashy to stand out. As long as you have a personal website, it just shows that you actually spend time building it and doing something that most people wouldn't do. Another thing that I want to show you is, for example, the job board that we have for all of my students. And this is, again, another open source project that the community built. If we just search through, let's say, Toronto developers here, and we go to Christine Aki, I hope I'm saying the last name right, you can see how simple yet beautiful her portfolio is. If we go to About Me, just a nice little bio with links to her profile. If we go to projects, we see some of their projects. And this is something that she can put on her resume and immediately stand out from the crowd. And it also gives her an opportunity to list projects that she can talk about when she gets to an interview. All right, let's look at the next topic. 1 to 2 big projects. Now, you can't really fake experience. If you've never built anything beyond a to-do list or a Hello World app, you simply will not be able to get very good jobs. However, most people think having 100 projects is the way to go. So they do a project a day and build small projects, many small, tiny projects to have 30 of them. And they start building all these projects that are very, very simple. Now, that's not actually impressive. I mean, it shows that you're working hard and coding along. But if I'm a recruiter and you show me a project of maybe tic-tac-toe, well, I don't really care. That's something that anybody can build with a bit of coding experience in a day or two. Frankly, no recruiter or interviewer is going to check out all your 30 projects. Most of the time, we want to hear your most difficult or the hardest, biggest project you've worked on. Instead of spending your time on these small little projects, spend your time on 1 or 2 big projects. For example, in other courses that I teach, we built a face recognition app. And this app, well, it has a front end using React.js, a back end where we have a RESTful API server with Express. We've deployed it to Heroku. We've created session management with authenticated routes. We store user information such as username and also hashed passwords securely in our database on Postgres. We've deployed our app with Docker, and we've also used Redis for session management and caching. Now, all of that may not mean a lot to you, but having something like a one big project that you can talk about all these things will make you sound a lot more impressive than somebody that just builds a ton of tiny projects. So focus on that. Have 1 to 2 big projects that you can show off, makes you stand out, and it's also going to give you something to talk about during the interview. And put it up on your website or create its own website, and you immediately can put this as the first item on your resume. Because here's the thing. If you don't have work experience, if we go back to the resume we used in the exercise, remember this resume? Well, if you had no work experience, maybe for work experience, you can say something like JavaScript developer or web application developer and talk about how you build your project here. Because to a recruiter, it doesn't really matter if you worked at a certain company building an application or on your own. Or that could be a little bit vague too. They don't need to know that. They just need to know that you built things that are real, that are big and complicated, and you solved hard problems. So Having 1 or 2 big projects that you can list on your experiences is a great way to add to your resume if you don't have enough past work experience at companies. And I have a few students who have actually used this technique to get interviews, even though they just learned how to code 6 months ago. And then finally, we have the blog post or blog. Let's have a look at what I mean by that. This is another thing you can include in your resume, especially if it's related to a technology you're using or the company is using. For example, I have here my Medium profile, and Medium.com allows anybody around the world to just post a blog post. And it's very popular with the tech community, so there's a lot of tech-related posts that you can write on Medium. And there's other platforms like this. What if you wrote a blog post about a specific technology that the company you're applying for is using? Or some sort of a technical problem that they're facing? By doing that and just adding a link to that blog post, it gives you, again, another leg up to most people. And the great thing about platforms like this is that, well, if we go to one of my articles here, you can post it to what we call publishers. And publishers allow your post to be discovered by others. And it's very simple to do. You can write a blog post on Medium in a day and submit it to a place like HackerNoon, and lots of people see it. And as soon as you show this to a recruiter or an interviewer, again, it automatically shows that you know what you're talking about, or at least it makes you stand out from the rest. And you can do this with YouTube videos as well, but I prefer writing because it's a lot faster and it looks a lot more professional. So let's just review here. What happens if you don't have enough experience? Well, all of these 4 points allow you to gain that experience or show that you have experience without actually having traditional work experience. All you need to do is start something on your own and build something like a project or a portfolio or a blog post. This only shows initiative, but you can focus this project on solely getting your interviews, or you can participate in a hackathon or contribute to open source projects. By taking this initiative, you're doing more than most people that hope to just land an interview by sending a generic resume. You'll immediately stand out from the crowd and give you something to put on your resume that, again, is different than the average developer. Plus, you have the added benefit of something to talk about in your actual interview. Remember, nothing is given to you for free. And luck is for those who rather wait than go after what they want. So by simply building something just for fun, such as a side project, you're showing how self-motivated and ambitious you are. Experience doesn't mean on-the-job experience. Write about your portfolio projects. Maybe talk about your website and how you built it. Talk about your GitHub profile, maybe a hackathon you participated in or open source projects you've worked on. Write a blog post on a specific technology that the company you're applying to is using. All of them answer this question: do you have experience? Finally, there are many things that you can add that are not developer related, but can make you a great employee. For example, did you work as an instructor at a camp? Well, you can now add ability to manage people and communicate well with others. Any skill that is related to getting the job done can be included. Also, if you have only had 6 months of coding experience, don't show that on the resume. That doesn't mean to lie, but to hide that information. Because a recruiter only glances at your resume. They won't care if you're the best developer in the world if they just see 6 months experience. That's too risky for them. Your resume will most likely be discarded no matter how good of a developer you are. So remember, resumes are only good to get your foot in the door. By tweaking your resume to show that you have experience so that the recruiters thinks, oh, interviewing this person is low risk because they know what they're talking about, is a good way of doing it. Do you have past experience? Have you made good decisions in the past? And have you worked on a challenging problem and solved them? If you're able to answer yes to that, well then, a recruiter is most likely going to ask you for an interview. I'll see you in the next video. Bye-bye. Welcome back. LinkedIn is one of the best things that has happened to the job market. Now, depending on your geographic location, you'll see different levels of activity for LinkedIn. So this is something that you'll have to consider for yourself and make sure that LinkedIn is a good option for your location. Now, let's have a look at LinkedIn so we can talk about it and also to see if it's a viable option for yourself. The best way to actually see if it's worth your time to invest in a LinkedIn profile is to actually just do a search for jobs. And in here, you can do all sorts of filters. But if I go to all filters, you can look for jobs based on your location and the type of job that you're looking for. If there are jobs, then perhaps you need a LinkedIn profile because, well, this is a great way to apply to jobs, which you can do on LinkedIn, but also have recruiters contact you through LinkedIn, which actually happens a lot. And we're going to get into that a little bit later. I personally think that LinkedIn is 100% better than resumes. And it's something that every single person should have, especially if you want a job in the tech industry. And by the way, I'm no specialist when it comes to LinkedIn. And there's a lot of people and books that talk about how to optimize these things. However, if you craft things well enough, you'll find you'll get contacted by recruiters constantly on LinkedIn. I actually have to add on my profile a little bit of a no recruiters please because I would get contacted so often by recruiters. From my experience speaking with other people, when you have a good LinkedIn profile, you'll get contacted for job offers, which again is a great thing to have in the back of your pocket as an extra way to increase those odds of getting an interview. So here's the keys to LinkedIn, fast and quick. Number one is to look for jobs and apply to jobs through LinkedIn. Again, I showed you how to do that. You can see what jobs are available and actually apply to them directly. LinkedIn is pretty much like your resume. So it should have very similar items as your resume. Whatever makes your profile complete, well, you should add it over here, just like I have done for myself. Now, the interesting thing here is that recruiters for other companies and tech recruiters usually search LinkedIn for candidates. And what they do is they do keyword searches. So if I'm a recruiter looking for, let's say, a Python developer, I'm going to Google Python developer and maybe check that a LinkedIn profile has the word Python in it. Maybe I'll check that if I scroll down here that their endorsed skills, where are they? That skills and endorsements that this person has Python. And perhaps whether this person changed their profile recently. And that's a little trick. Update your profile every week when you're looking for a job on LinkedIn, since it's going to show up in a recruiter's search result. So even if it's a small change, such as just a little typo or a little space, it's going to show up as an updated profile. And recruiters are actually going to see that this person changed their profile recently, which means they're more likely to be looking for a job and they're more likely to reach to you. So you can actually just do this every couple of days when you're looking for a job so that it increases your odds of you getting onto recruiters' search results. You also want to include keywords that recruiters are looking for. And I have an example here for you. If I scroll to one of my positions here, I have a list of my favorite tools in 2017. And I actually did this strategically because all these tools that I'm using are now keywords that if a recruiter or company is looking for somebody with MongoDB experience or maybe serverless architecture or Firebase or any of these things, my profile includes those. So I'm going to show up in those results. So think of it that way. What are the keywords that will make you more approachable? Finally, try to get recommendations from other people. Message your friends or colleagues or coworkers and get them to refer you. Not that recruiters or companies will read this, but again, when your profile shows up in searches, it's more likely to be ranked higher up because you have these recommendations. By the way, these skills and endorsements are things that, well, usually you get from people such as your connections on LinkedIn. It's really hard to get this number up. So I've actually created a little group for us where if I go to groups, and by the way, LinkedIn is updating these. So it's going to actually change most likely from how you see it in the video. And here we have members that you can connect with and actually ask for referrals, skills, and endorsement, just to again boost your LinkedIn profile. Finally, something that we're going to talk about in the email section, but some of the best way to get jobs is to not just blindly email companies that don't know anything about you. Getting referrals or being referred by somebody within the company is one of the best ways to do that. And for me, myself, I'm not very sociable. I don't really like networking and going to events. Or perhaps maybe I don't know somebody at a company and there's no way for me to get a referral. Well, LinkedIn allows us to do this by simply searching for, let's say, Netflix. I want to work at Netflix. I'm going to click on this company. Or actually, if we go back and do Netflix and click on Netflix in people, I'm going to look for people that work at Netflix. If it works, oh, there you go. A little bit slow there. And I see here people that actually work at Netflix and some of my connections to them. I see that I have shared connections and I can message somebody, I can connect with them. I can also see that, this person is actually a recruiter at Netflix and I have some sort of a shared connection. Maybe I should message her and see if I can get an introduction, or maybe I can pass my resume on to her or set up a phone interview. In other words, LinkedIn allows us to see that we have mutual friends and we can vouch for each other's credibility or perhaps contact somebody directly at Netflix that can get us an interview. Again, it's all about being strategic and efficient and doing what most people aren't willing to do, which will make you stand out. All right, so to review. Update your LinkedIn profile with the skills that you have and according to the jobs that you're targeting. Recruiters are going to use LinkedIn to look for candidates, and they'll always search for users who have recently changed their profiles, since it signals to them that this person's looking for a job. And also try to include the relevant skills and have those keywords ready so that you do show up in those search results. You can also apply to jobs directly through LinkedIn. And you can also find people or companies that you want to work for that you can connect with, message, or get referrals from. Again, something we'll talk a little bit more in detail in our email section. Using a tool like this that allows you to be discovered while you're sleeping just optimizes your chance of getting interviews without making you spend a ton of time trying to get those interviews. Again, so you can focus on things that really matter. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about portfolios. And actually, we kind of spoke about this already on our video about what if you don't have enough experience. So I'm just going to go over a few things. So I recommend you make sure you watch that video first. Otherwise, let's just recap what a portfolio should be. A portfolio is simply a way for you to showcase your big projects, the items that you want to really demonstrate your value with, to talk about in the interview. Those personal projects should reflect what kind of job you want. So don't spend a lot of time on your portfolio. It doesn't really matter that much how it looks unless you're a designer. Using a free resource like the one I showed you that gives you free templates where you can list your projects is enough for you to just have an online link on your resume and for recruiters to possibly see that you have some sort of an online presence. So using something like this or Creative Tim is a great way to just speed up that process. Remember, the projects inside this portfolio is what matters most. You just need to have 1 to 2 big projects you really care about. I've actually never met a developer that has gotten a job solely because they had a nice portfolio. So don't stress too much about it. Remember, your goal is just to be seen, just to get that interview. Your portfolio can be quite simple. You just want to make sure that it looks somewhat nice and that it also loads up fast. And you just need a place to showcase your main projects. A place maybe to add your blog posts, maybe to add your GitHub account. And I'll leave a nice resource for you for some of the best portfolio websites, but they all pretty much look the same. A little About Me section, links to GitHub and blog posts, and just a list of your projects. You can even have your resume on this portfolio. And by the way, once you're done with your portfolio, I recommend you add it to the job board that we have here so that you can showcase it for other students of the course. But I also include this on my LinkedIn profile so that when recruiters see my profile, they can just search for developers that they need based on name, job title, location. And it's just a nice way to get seen or have at least another avenue to be discovered. And that's it. Again, spend very little time, but just have something out there. I also recommend going to our Zero to Mastery community and actually going to the job hunting section. And we might have a few more channels by the time you watch this video, but you can check out other people's profiles as well as talk about job hunting, and people sometimes share job openings here. This is a great place to ask for help, get tips, and maybe help out community members as well as we all try and get that dream job. Anyway, I'll see you in the next one. Bye-bye. Welcome back to our fourth and last item on the list, emails. Now, if you're applying directly via a company's website or through a job board, please stop. Well, all right, don't actually stop, but realize it's not the best way. It's what everybody else does. There's a study that was published by a company called Impact Group, and they looked at some of the job applications and did some statistics around those numbers, and they found that close to 30% of hires made by organizations actually came from referrals. So that is employees referring their friends or somebody that they know to the company. It was the number one way of companies to hire other people. And again, part of this study also discovered that 46% of men and 39% of women actually find their jobs, most of their jobs, through networking. The interesting thing is that the higher your salary, the more effective networking becomes in getting a referral. For most companies, the best way to get an interview is not only through online job boards, but the best way to get an interview is through referrals. But lucky for you, this doesn't have to be an actual friend or a coworker. Usually you can message people within a company using some of the tools that I'm going to show you. All right, let's get started and show you the first example. All right, the first way, well, the most obvious way is to actually apply to companies where your friends and colleagues can refer you. But maybe that's not the case for everybody, and that's kind of rare. As I've shown you in the LinkedIn video, there are ways for you to actually connect with employees through LinkedIn and message them based on who you're connected with. And you can usually send them a polite or smart email. And this is an example template that I'll share with you that a user, Patrick McKenzie on Hacker News, shared, and it's a really, really good piece of text. I'm not going to read it out for you, but you can see over here a short email to get yourself a referral, or at least talk to some of the developers of the company or some of the key players that might get you an interview. But again, how can we solve this problem of finding the people to contact? Well, the one way to do this is using LinkedIn. Like I showed you, I can see what jobs, let's say Netflix is hiring for. I can see some of their employees here. I can see that I have some connections here from my school. So that's an easy way, but what if you're not able to use LinkedIn or able to find these connections? There's some great tools that you can use to find, in this day and age, pretty much anybody's email. And I'll link to this after this lesson, but you have a lot of plugins, such as this one over here, that finds emails of LinkedIn profiles. You have Hunter over here that you go on a website and it shows you what emails are associated with the website, and other tools like Email Extractor. Using that, you can target somebody that might be a gatekeeper. That is, somebody that can make the decision to interview you or not interview you, or can refer you to somebody that has that decision. Because nothing beats getting a referral from someone. And the other beauty is that most big companies have incentives for employees who refer someone. So they may actually be willing to help you. What do I mean by that? For example, my past company, if you were able to refer a developer, you got an extra bonus on that month's salary because they're always looking for good employees. And they know that referrals usually turn out to be better candidates than somebody that just applies randomly online. By contacting some of the people that might be able to refer you, they actually may be interested as well because they might get a bonus from the company for referring somebody that they're going to hire and thus improve the company. Keep in mind that you don't have to just do this online. You can meet people at meetups that you might have locally, or even hackathons where you can meet people in real life and ask them if the company they work for is hiring. There's just so many ways to do it, and be smart about it. Again, nothing beats getting a referral from someone than just blindly sending out a resume. But let's go back to the slides. The methods we just discussed for emailing and getting referrals are pretty basic. So let's get creative. Instead of sending your resume, I usually email a company I'm interested in. And again, you can use some of the free tools that I showed you, such as Email Hunter. And instead of sending a resume, instead send them a personal website that you have, a portfolio, why you want to work for that company, and ask them if you can come by for an interview. Just ask them outright. You can send this message to the head HR or human resources person or somebody on the development team. Another way, or even more creative way, well, message lead developers or CTOs, somebody in charge of the developers or engineers at the company, that you're interested in working for them. And let them know that you're interested in getting where they are professionally. Ask them to take them for coffee or lunch, or ask them if you can come by to the office to chat with them about their careers so you can learn from them. People love talking about themselves, and if you're not outright asking for a job, instead you just want to pick their brain or learn from them, you might be surprised how often you'd get the, yes, come by and let's have coffee. The key here is to just not ask them for a job. And at the end of meeting them, perhaps inquire if they have anybody that they recommend you speak to. If they're not looking to hire, they'll direct you to someone else. And then finally, another way that I like reaching out is to perhaps message CEOs directly or president of a company. And this is something that works with smaller companies. Big, large companies, this most likely won't work. But if you message the CEO of a startup and ask perhaps what technical problems they're having, tell them what technologies you're an expert in, and ask to solve a real-life problem that they have free of charge, they can keep the work, and in return, all you ask for is an interview. I mean, they might take you up on it because, hey, why not? I remember one time when I was a little younger, I messaged the CEO of a really big travel company saying that the book that they wrote really inspired me and that I'm starting my own travel company. And the CEO and I actually had a meeting and we spoke for about 2 hours discussing whether I should join his company or not. And I never asked him for a job. It was just something that I sent out. Again, doing things that most people wouldn't do. But at the end of the day, the point of this is to not necessarily send out mass amounts of resume. Select the jobs that you want, personalize your emails, and try to avoid sending a resume if you can. Try to bypass formalities of the application process by trying to get an interview right away. Most likely during the interview, they will ask you for a resume, but by that point, it doesn't really matter. You've already gotten what you wanted, the interview. By the way, you may have noticed that this is what cover letters should be. An email to introduce yourself. Cover letters should actually be just directed at someone and personalized. So don't bother creating a generic one. They're just simply emails to reach out to somebody. to get referrals to get that interview. Just write an email or any way to get connected to show how you can help solve their problems. I'll see you in the next video. Bye-bye. Welcome back. We're going to answer a question that's kind of simple, kind of not, depending on your situation. But I do get asked this question a lot, so I wanted to cover it. Where to find the jobs? Now, as an engineer, as a programmer, as a developer, we have the skills that are quite in demand. Most of the time, you're not going to find difficulty, or it won't be very difficult for you to actually find companies that hire for your skill sets. The good news is that the better you get at programming, the better you become at engineering, well, the more doors open up for you. So that's the good news. You can always improve your skills, and we have a highly in-demand skill that allows us a lot of freedom. So when it comes to where to find the jobs, there is a ton of resources out there. But I'm going to show you my favorite ones that I think are worth your time because, again, there's so many options that you want to focus on quality over quantity. Let's have a look. The first one is LinkedIn, and it's something we've already talked about, but I really do think it's a great option that if this is available to you in your location, then you should be using it 100%. Another place that I like is Hacker News. So Hacker News, a lot of engineers and programmers hang out there, and they actually do a monthly Who is Hiring section. You can see over here when I'm recording this video that they have Who is Hiring, and it shows you all the companies or people comment with companies that are currently hiring right now. Again, really, really good if you're interested, especially startups. They sometimes have remote jobs as well, which is really good. Another great resource. If you're specifically looking for startups, then AngelList is probably the best place to go. So signing up for AngelList, creating a profile, and finding a job, you can work for some of the hottest startups right now. If you're looking for remote jobs, again, I'm going to leave a few more resources after this video, but this is one of my favorite websites if you want to look for remote jobs. Again, they're becoming more and more common that no matter where you are in the world, as long as you have an internet connection, you can be a developer, a programmer, an engineer, and work from a company that's thousands of kilometers away. And I have more and more friends that work remotely as programmers now because more companies are becoming used to the idea of having remote workers. Another interesting way to apply for jobs are companies like Hired, TripleByte, or White Truffle. They all have pretty cool sounding names, except for Hired. That's pretty generic. But what they do here is they actually have companies reaching out to them to hire good developers. So you would take some sort of a quiz, a coding quiz with them. They give you some sort of a rank, and they create a profile for you so that companies reach out to them and look at your score and hopefully hire you. I'm not the biggest fan of these because it does take a bit of time to take these quizzes. I like being direct and picking the companies that you want to apply for, but they do have some pretty respectable companies that use some of these websites to hire people. Then there's also meetups. Again, going to your local meetups for a specific technology that you're working with is a great way to network, meet people from other companies, and potentially see which companies are hiring. I personally am not a big fan of networking. It doesn't seem genuine and kind of seems like I'm faking relationship, but for other people, it works really, really well. Again, a great way to find people, connect with them, and especially get referrals. Finally, one of my favorite ways is to do this type of search on Google. You see over here, I have site, LinkedIn.com. So search LinkedIn.com and then search for Facebook Recruiter. If I want to apply at Facebook, well, I see over here, Colleen Dunn and Juliana. are regional recruiters, recruiter at Facebook, university recruiter, and I can find specific people that I want to get in touch with if I want to work at something like Facebook. And I can obviously change this to whatever I want. And that's a great way to target your approach. Because remember, job hunting is a numbers game. A 2% chance of getting an interview means all you need to do is apply to 50 places to get an interview, or something along those lines. You just want to increase your percentage, your odds of getting that interview. Keep that in mind. Just applying to companies blindly is not a good idea. I mean, you will get interviews, but it's not very efficient. If you have companies you love or you want to work for a specific company, sometimes targeting your approach and focusing in on that company is a lot better, more efficient way of spending your time. Hopefully this was useful. I'm going to list a bunch of these resources that I showed you and a few others in the next lesson, and I'll see you in the next video. Bye-bye. When should I start applying for a job? This is especially common for people who are looking for their first coding job because they're new. They aren't sure how valuable their skills are, and we all have heard of the imposter syndrome, where we think that everybody knows a lot more than us and that we are just an imposter pretending to be engineers. So I want to answer this question for you. A short version and a long version. Short answer, when should you start applying, is, well, now. Because you need to start looking at interviews not as a win or lose, fail or pass. Rather, as with anything, it is a skill that you can improve and get better at. Each interview that you go to will make you a better interviewer. Practicing is the key here, and the sooner you start interviewing, the better. Now, there's a catch here, and we'll need to go into the longer answer for that one. Assessing readiness is related to calculating the actual value and salary of a developer, and that's tough to do. When will you know that you're a front-end engineer or a back-end engineer? Most of the time you see on the job description items that you don't even know of, or are not the master of, or requiring way more experience or way more years of experience than you have. First things first, companies do this to filter out the weak candidates. As a matter of fact, if you're applying to a job where you check all of the boxes and you know everything, then that means you are getting a job where you already know what to do. You won't grow in this role as much as tougher positions, will you? So you need to change your mindset here. A job description is simply a guideline of what type of work you will be doing, not what type of work have you done in the past. With that said, if you don't know how to code at all and you apply for a developer position, well, don't expect a positive result. You need to have some fundamentals before you actually start applying. Luckily for you, the criteria is very simple. Do you know the fundamental building blocks of computer science, like data structures and algorithms, like we're going to learn in this course? In your specific domain, have you built some projects and can build something on your own, other than a simple Hello World project? Do you have one or two big projects using the related technologies that the job description has? If that's the case, well, you should start applying. Your skills will continue to grow, and I can count numerous times when people at my company got hired over people with more experience. Because hiring developers or engineers is more than just technical knowledge. Once you meet a baseline, that is the minimum requirement, the rest comes down to non-technical parts of the interview, again, which we have a whole section on in this course. So when should you apply? Now. Use it as practice. Just like with anything, if you wait until you feel you're ready, you already waited too long. Remember this quote: if you never ask, the answer is always no. So start applying now. I'll see you in the next video. Bye-bye. Whew, we're done with this section. Now, let's review what we've learned. And before I do that, I'm going to tell you something that is counterintuitive. Don't apply to 1,000 positions online just sending out your resume everywhere. That's what most people do. Instead, pick 5 to 10 companies you want to work for and fully target and focus on applying to them. You see, that is the main goal that we started with. Increase our chances of getting an interview. All of our actions create that, and a week's worth of work will set us up for future success. Setting up something like a good resume, LinkedIn profile. We keep our options open as people contact us. Like I said at the beginning of this section, most of this should take you a week to set up. As you go on and you may get feedback, you can keep updating things. The only thing that may take you longer is perhaps 1 to 2 big projects for your portfolio. But that is a good investment because not only are you learning how to build things, but it will give you things to talk about in the interview, and you're actually coding instead of just typing up a resume that doesn't really help you as a developer or an engineer. We talked about email and contacting people directly and getting referrals as a better way to apply than being completely anonymous. We talked about how to overcome the lack of experience. When you're ready to apply, the short answer was now, and where you can find jobs and the most efficient way to apply. If you've noticed, the focus is on quality over quality. Even though I said it's a numbers game, your time is better invested in focusing your approach. All right. That's enough. I apologize for this section. I know it's not the most exciting section. It's really hard to make resumes exciting as a topic. But we're going to get to the actual fun coding technical part now. So thanks for sticking with me. It's going to get a lot more fun. And I'll see you in the next section. Bye-bye. In this course, I don't want to limit you to just one language because we all code in different languages, and throughout your career, you're most likely going to use multiple languages. Now, this course specifically, I will have to use a language to demonstrate code and write some code. And I'm going to use JavaScript for this because it is similar with a lot of common languages, and it's also the most well-known. However, you can use whatever language you want in this course and follow along. Even the exercises will give you solutions in different languages. So pick whichever one you want. But how are we going to run all these different languages when you're following along? Maybe I'm demonstrating something in JavaScript and you're coding along in Python. Well, we're going to use a couple of neat little online tools. The first one I'm going to show you, and the one we're going to use in this course, is REPL.it. REPL.it, as I like to call it. And you can pick any language that you want here to code along. And like I said, I'm going to be using JavaScript for this course. But all you need to do is to sign up with your GitHub account, and you'll have a little IDE that you can run your code in. And you'll see me using this throughout the course. Another one that I really like is Glot.io. And it's open source, which I'm a big fan of. And you can see over here that we have a lot of different languages that we can use. Again, if I go to JavaScript, it gives me a nice little area for me to write code and run it. Another option, especially if you're using JavaScript, is to just go to View, Developer, and Developer Tools in Google Chrome. And this allows you in the Console tab to just write JavaScript. So that's another great option. Or if you prefer, you can always use your favorite text editor, write your code, and then run it whichever way you want. Again, keeping in mind that this course is language agnostic. That means it doesn't matter what language you use. What we're learning are foundational computer science principles that you can take anywhere throughout your career. And as you'll see, whether you know JavaScript or not, I'm going to keep the code very general and simple so that it's easy to replicate it into other languages and also give you resources and sources with other languages when we get into more nitty-gritty coding. All right, Set up your environment, get ready for some code. I'll see you in the next video. Bye-bye. In my opinion, this section is one of the most important topics for any software developer or engineer. It also happens to be my favorite section of this course. No matter what company you work in, where you live, or even if you're coding 10 years from now, this is a concept that will be around for a long time and something that will truly make you a better developer. Big O is something that I learned about 2 to 3 years into my career as a developer. And it's so important. It has made me a better developer, a better engineer. And it will for you as well. Big companies like Google, Facebook, Alibaba, Amazon, all know this, which is why you won't get by any of their interviews, any of their phone interviews, any of their screening interviews without encountering this topic. So we're going to learn all about this very important topic, and that's why it's at the beginning of the course. All right, did I grab your attention enough? So what are we talking about here? It's called Big O, and the official term is Big O asymptotic analysis, if you want to sound super smart and impress your friends. You see, any coder, given enough time, can solve a problem. What matters is, though, how well the problem is solved. And this is where Big O can help us. It can tell us how well a problem is solved. We're going to find out about what that means in this section. We're going to talk about Big O, what it is, how we define it, and then we're going to use Big O and its different notation to distinguish bad code from good code from great code. We are going to become comfortable with this topic, that we are going to not be surprised when this comes up in our interviews. But we are also going to build this big foundation that is important to be a great developer. The reason this topic is at the beginning of this course is that you will see this Big O notation come up again and again as we go into topics such as data structures and algorithms. Like I said, this is my favorite section, so get ready because it's going to be a lot of fun. See you in the next video. Bye-bye. There are two main things we talk about when we say this is good code. But before I show you, what do you think good code is? Think about that. What would you tell somebody if you're asking them to write good code? All right, I'll just give you the answer. You see, good code can be described in two things, or 2 points. One is readability. Is your code just generally clean? Can others understand your code? And then we have scalable code. What does that mean? Well, Big O notation is what allows us to measure this idea of scalable code that can scale. Something that we're going to get into and you're going to become more familiar with as we go through this section. We're also going to talk about readable code throughout this entire course, but touch upon it a little bit more in the next section. But for now, because this is the Big O section, we're focusing on this idea of scalable code. Okay, what does this really mean though? Well, I want you to imagine we have a task where we want to bake a cake. We have a recipe over here, and this recipe we're going to use in our kitchen to bake a cake. And there's a good way of baking a cake and a bad way, right? We give it the instructions, that is the recipe, and hopefully this recipe and instructions work well with our kitchen so that we can bake a cake quickly, and a good cake at that. Well, computers are machines, and these machines need to work in order to produce something for us. And computers work in the same way. We have these instructions that we give it through code, and these instructions that we give to our machines, our computers, give these instructions that provide for us some sort of an output. For example, to turn on the light. We give the computer instruction to say, hey, turn on the light in our room. A coder is someone that gives these instructions. Just like there are many ways to take a cake into a kitchen, or just like there are many ways to bake a cake, in the kitchen with many recipes, ingredients, and instructions, there are many ways to solve a problem through code. There are efficient and inefficient ways to give instructions. So let's go to a coding example. I'm going to use REPL.in. And if you're not familiar with this, make sure you check out the video that I've listed down below here, which explains how you can run your code in this course. I'm going to just log in. And I already have my JavaScript environment set up over here. And I prefer having the dark theme. I think that looks better on your eyes. For you at least, I hope you don't mind the darkness. But how can I demonstrate this idea of code? Let's do something fun here. Using JavaScript, I'm going to say const Nemo. We have an array that contains the string Nemo. And we want to create a function here that is called find Nemo. And this function is going to receive an array. And it's going to be a very simple function. We're going to create a loop that you'll see in most languages. In JavaScript, we can do that easily by saying for, and we'll give let I equals 0. And as long as I is smaller than the array.length, that is the length of our array, and then we're going to increment I every time. Again, this isn't a JavaScript course, so hopefully this is familiar to you. Any sort of loop that you want in your language. And we're just going to simply say that if array I equals Nemo. So if we find Nemo, we're just going to console.log found Nemo. We're very excited we found him. All right, that's it. And if I just simply run the function now, find Nemo, and we'll just give it the array Nemo over here, and make sure that I spell length properly, and we click run here, we have found Nemo on the right. Let me make this a little bit bigger so you can see. So we found Nemo. This is the instruction that we gave the computer. We told it that we have an array and we have a function, an action that we want to perform called find Nemo that takes an array, which is Nemo. It's going to receive this array. Then it's going to loop over the array. We're going to say that I is going to equal 0. And because I is 0 right now and the array.length of Nemo is 1, we're going to go through the loop. We're going to check if array index of 0, which is Nemo over here. So this is going to turn into Nemo. And because this is true, we're going to console log found Nemo. Now, why did I just show you this example? Let me just bring this back to the way it was. I showed you this example because this is an instruction that we're giving our computer to find Nemo. You see, we call this the runtime. How long does it take to run a certain problem through a function or a task? How can we measure the big O of something like this, or the efficiency of this code? In the next video, we're going to get a little bit deeper. We're going to try and measure the performance of this code and see what happens when the array gets larger and larger. And we're going to tie things together as to what scalable means and how big O allows us to measure this scalability. See you in the next video. Bye-bye. Welcome back. Let's continue our discussion of what this scalable idea means. You remember that we talked about the kitchen and how, similar to a kitchen, we have to give instructions to our machines to produce a result. And in the previous video, we talked about this function, finding Nemo. Let's measure the performance of this function. Well, JavaScript gives us a nifty little tool that comes built in to the browser, which is where we're running this code. So depending on your language, you might not have this option, but you will have different ways of measuring this. Don't get too hung up on this. We want to use this as an example to measure how long it takes for this function to run. We can do this in JavaScript by saying, let's say time 0 is going to equal performance that comes built in to the browser, and we just say now. And this t0 is going to start this timer before the loop happens. And then when the loop ends, I'm going to have another timer called t1, and this is going to equal performance.now. So we have two timers, one at the beginning, one at the end after the function goes through the loop to find Nemo. And then at the end, we'll just do a fun little console.log, and we'll say that the call to find Nemo took, and we can just do a simple t1 minus t0, and then we'll say milliseconds, because it's going to give us the results in milliseconds. Let's see if this works. I'm going to run this code, and let me add a space in here, and we see that it took 0 milliseconds for this code to run. Let me run that again. 0 seconds, again, 0 seconds, 0 seconds. And if I keep clicking it, I see that, oh, now it takes a little bit longer. And that's because this is really fast, right? Our computers, machines are extremely fast in this day and age. And because we're only looping through this once, well, it takes almost 0 milliseconds. And the display just rounds this down. But what if we had a bigger array? Let's say that we have an array over here that has const everyone, and it has all the characters, or at least a lot of the characters from the movie Finding Nemo, which, if you haven't watched it, amazing movie, highly recommend it. Anyway, we see that we have a lot more characters now. So instead of just having a single array, let's have the array everyone in here. And this array now has a lot more items. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 loops in here that we're going to do. If we run this, we see that the time is still the same, pretty much 0 milliseconds, sometimes a little bit more, and the time changes all the time. But we don't see that much of a difference, do we? I mean, we went from 1 loop to now 10 loops, but it's still super, super fast. And again, that's because our computers in this day and age are quite fast. The difference between 1 loop and 10 loops is not that big. But let's do a little fun trick here. In JavaScript, we can create a large array. Let's just call it large. And we can create a massive array by just saying new array. And we'll give it 100 items. And this 100 items in the array, we can fill it with, let's say, Nemo. And this is just going to create an array that has Nemo 100 times. So instead of everyone, let's do large and hit run. All right, we see here that it's found Nemo 100 times because, well, we just filled it with Nemo. And at the bottom, we see that it took 0.5 milliseconds. That took a lot longer, didn't it? Let's do even bigger. Let's do 1,000. Hit run. It took 7 milliseconds now. What if we do even bigger? What if we had a massive array of 10,000? If we hit run, 46 milliseconds. It's still pretty fast. And then just for fun, one more. If I hit run, you saw that delay and how long that took. That took 343 milliseconds, or 3.4 seconds. Now, what did we just see here? Well, we see that as our input grew, our function, find Nemo, became slower and slower and slower. Our runtime, how long it takes to run a certain problem through a function, increased. But Here's the problem here. If you take this code and run it on your computer, well, your time is going to be different than mine. And I'll leave this code at the end of this video so you can play around with it. You're going to get frustrated because every time you run this code is going to be different than my number. It might be a lot faster or a lot slower. You see, this all depends on how powerful the CPU in the computer is and what other programs are running on your computer, what programming languages you're using, and many other factors. So there's all these factors that play here in our runtime. Therefore, if I speak to my friend across the world, let's call him Johnny, and if I tell him, hey Johnny, my code is so amazing, I've created this find Nemo function and it runs in 3 seconds, 3.2 seconds with 100,000 inputs. How good of a coder am I? And then Johnny says, that's really awesome, but you know what? Mine runs a lot faster. It runs in 1.5 seconds. So I win. What do you think? Do you think Johnny wins? Does Johnny have better code than I do? Well, here's the thing. Not necessarily. This doesn't really mean much. Because it matters what type of computer Johnny has, what other factors, as I mentioned before, the code is running in. So how can we determine who wins? Do I win or does Johnny win? Who has better code? And this is very common in the computing world. We code on our laptops, our computers, but that code doesn't necessarily run on those devices. If we have something like a server, we may have that code run somewhere else on a different computer around the world. So how can we make sure that there's a way for us to measure, in terms of efficiency, what is good code and what is bad code? And what is code that can scale, that as the number of arrays or inputs increases, it doesn't constantly slow down more and more. Big O notation is the language we use for talking about how long an algorithm takes to run. We can compare two different algorithms, or in this case functions, using Big O and say which one is better than the other when it comes to scale, regardless of our computer differences. And we can measure Big O like this. I'm going to warn you that this will look really confusing at first, and this is the first time we're seeing this diagram. And don't worry, by the end of this section, this is going to make sense and you're going to be completely fluent in this. So just trust me in this. Keep following these videos. I know I'm kind of circling around the topic and not being direct as to what it means, but I promise you, by the end of this, this is all going to make sense and you're going to be a Big O ninja. When we talk about Big O and scalability of code, we simply mean when we grow bigger and bigger with our input, how much does the algorithm or function slow down? If the list of characters, let's say elements here, so that is Nemo, so characters in Finding Nemo in our array, as that increases, how many more operations do we have to do? That's all it is. This is what we call algorithmic efficiency. Big O allows us to explain this concept. Remember how in our function we initially had an array of just one, which was Nemo? So that is the number of elements, number of inputs in a function. It was right here. But then as we increased that array to have more characters, and then we created that massive array of 100,000. So as that increases, you saw that the number of operations or the number of things we do in the loop increased over and over. And different functions have different Big O complexities. That is, these number of operations can increase really, really fast, like this one, which is not good. You can see here that it's horrible. And things that are quite good, actually, and don't increase as much. And we're going to look at examples of different ones and how to actually measure this and what this entire notation means. But to end this video, so we can dive deeper into the topic, just remember this point. When we talk about Big O and scalability of code, we simply mean when we grow bigger and bigger with our input, how much does the algorithm slow down? The less it slows down or the slower it slows down, the better it is. So instead of using performance done now and using time to measure the efficiency of our function, we can just calculate how many operations a computer has to perform, because each operation takes time on a computer. So big O allows us and concerns us with how many steps it takes in a function. All right, let's dig in deeper and deeper into this topic. I'll see you in the next video. Bye-bye. What would you say if I asked you, what is the big O of the function finding Nemo? Well, to make this a little bit cleaner, let's just remove performance done now, because we've learned that it's not very, very important. And we can remove the console log as well. And looking at this and this loop, what would you say the big O is? In this video, we're going to learn about our very first big O notation. As we said, a runtime is simply how long something takes to run. How does this function and its runtime grow as our input increases? As our input goes from just a single item in an array, Nemo, to 10 items in an array, to 100,000. How does the efficiency of this function increase? If we look at this graph and we say we have 4 items in the array, well, the number of operations is going to be 4, right? Because we're going to loop through each item and say, is this Nemo? Is this Nemo? Is this Nemo? Is this Nemo? 4 times. No matter what, we're looping 4 times, at least with the way that we have this code set up. If we have 5 items in the array, it's going to be 5 operations, 5 loops. 6 is the same. 6 items is 6 operations. 7 is 7 operations. And 8 is 8 operations. Do we see a little bit of a pattern here? Well, we can draw a line through it. This is linear, right? As our number of inputs increase, the number of operations increase as well. And here, ladies and gentlemen, we've learned our very first big O notation. We say that the finding Nemo function has a big O notation of O n. That's a little bit strange. This is just a notation that you have to get used to. But we say big O of n, or what we call linear time. It takes linear time to find Nemo. Now, where does this n come from? This n can be anything, really. I could put x, I could put fish in here if I want. It's just an arbitrary letter, and we usually give n when it comes to big O. This is just a standard that you'll see across the board. N simply means the big O depends on the number of inputs, the number of fish. So if we just had the Nemo array, this would just be 1. If we had the everyone array, this would be 10. And if we had the large array, it'll be 100,000. But as the inputs increase, you see that the number of operations increase linearly with it. ON is probably the most common big O notation you'll find. If we go back to the graph, you can see that ON is right here in the yellow region that says fair. As the number of elements increase, you see that it's just a straight line. The number of operations increases by the same amount. Because keep this in mind, big O doesn't measure things in seconds. Instead, we're focusing on how quickly our runtime grows. We simply do this by using the size of the input, which we call n, or anything else that we want really, and compare it to the number of operations that increase. That's what scalability means. As things grow larger and larger, does it scale? So the find Nemo function is O of n, linear time. Another way to think about it is this. if we had a compression algorithm, let's say this function is this little compression, and the input is this little box. What's the big O notation of this function? Well, if we had one element, it will just compress one item. If we had multiple elements, again, we still have to run each box through the compression algorithm to compress the box. If we look at the function for the compress boxes, well, we're using the ES5 and ES6 syntax here, but we're essentially looping through each box. And in our case, we're just console logging it. But you can see here that all of these, all we're doing as the input increases, the number of boxes increases, the number of operations increase. And that is ON, linear time. Congratulations, you just learned your first big O notation. And this is probably the most common. But there's a few others. So, what other big O notations do we have other than linear time? For that, you're going to have to keep watching. I'll see you in the next video. Bye-bye. Welcome back. We just learned our first notation, O of n, or linear time. And we see here that we have a few others remaining. So let's talk about the next one. Another very common big O notation that you're going to see. What happens if we have a function like this? A function that says compressed first box that receives an array of boxes. And this function simply has console.log boxes 0. So that is, it's logging out just the first item in the box. What would you say the big O of this function is? How many steps or operations does this function take if the boxes increase from 0 to maybe 10, to maybe 100, to 100,000? What would happen here? Ready for the answer? Well, this is what we call constant time. It's an O of 1. That is, no matter how many times the boxes increase here, or however many boxes we have, we're always just grabbing the first item in the array. If we look at this with an example, if we had an array of boxes here, and we run it through the function that just takes the first item in the array, well, the number of operations is 1. No matter how big the number of boxes are, we're only doing one thing. So it's a constant time. If we look at this on a graph, if we have one element or one box, we do one operation. If we have 3, again, we still do just one because we're just grabbing the first item in the array. If we have, let's say, 5, same thing. 7, same thing. And what about 9? Again, same number of operation. And this is, I don't know if you can see the line, but this is just constant time. It's not linear time like it was, where it increases and increases with the number of operations. The number of operations just stays flat. But I have a question here. What if we do something different? What if we do something like this? What if we have a function that says function grab or log first 2 boxes? And this takes an array of boxes and it's going to console.log the first item in the array, and it's going to console.log also the second item in the array. How do we measure the big O of this function? Well, let me just comment this out for a second because we don't need this right now. And just create an array called boxes. And this boxes has, let's just say 0, 1, 2, 3, 4, and 5. So 5 items, or 6 in this case, because we include 0. And if we run this function, log first two boxes, and we give it the boxes array, and we click run here, we have 0 and 1. So we've logged this one and then this one. What's the number of operations here? Well, we have O of 1, that is one operation here, and then we have over here O of 1 again. Each time, this function runs two operations. So this function in total is actually running O of 2 operations every time. So no matter how big the boxes get, the number of operations here is going to be 2. If we look at this on a graph, instead of having O of 1 like we had before, we have O of 2. And then if we had 3 operations, it'll just be O of 3. But overall, it's still a flat line. And this is something we're going to get into later on. But when it comes to constant time, we don't care about the nitty-gritty O of 1, O of 2, O of 3, O of even 100. We round this down to just simply saying O of 1. That is, we have constant time. It's a flat line. In terms of scalability, it doesn't matter how big our inputs are. We're always going to do the constant amount of time on a function. And if we look at this on a graph, we see that O of 1 over here is the dark green area. It's excellent. We love O of 1 because it's very scalable, right? It doesn't matter how many elements we have, it's always going to run the same. Predictability when it comes to computing is very, very nice. And O of 1 is definitely excellent. Okay, so we've learned about linear time, O of n, and then constant time, O of 1. Let's do a bit of a fun exercise to really solidify our knowledge here. Welcome back. How much did you hate me after doing this challenge? Now, this was specifically supposed to be hard and difficult and frustrating, and most likely you're not going to get right the first time around. This was done on purpose to illustrate a point. What we're actually doing here, well, you won't be asked to do in an interview. But I wanted to show you how to think about things because later on, I'll show you how it's actually a lot simpler than thinking about each individual step in a function to calculate things. There's not much math involved, and this is as mathy as we're going to get in this course. But again, I just want to show you the nitty-gritty details so that you can think about it and have a nice foundation so that moving forward, we can simplify things a lot better. Now, let's look at this function. It's the fun challenge function that takes some sort of an input. The very first thing is within this function, when we run the fun challenge, let's just say we'll have fun challenge and we run this function and the input doesn't really matter. It could be an array, it could be an object. For now, let's just keep things simple, say it's an array of 5. Now, when we run this function, the first thing we're going to do is an assignment. We're going to assign variable a as 10. Now, based on convention, and this is why you won't encounter this in an interview because a lot of people interpret this differently. Some people say that assignment you shouldn't count towards big O, and some people say that you should. In our case, just to simplify things, let's count every single step and what the function is doing. Let a equals 10 is just O of 1 because this is only running once when we run fun challenge. That's it. It doesn't matter how big the input is. This just runs once. And then 50 plus 3, we're reassigning a. This, once again, is O of 1. And then we get into a loop. We know that with the loop, it looks like we're looking at the length of the input and looping over depending on whatever the input is. In our case, this is going to be an O of n. Let's add that comment over here. And this n is the input. Remember that I can change this to input. I can change this to x. It doesn't really matter. It just reflects how big the input is. That's how long this for loop is going to take. And we know this by now that loops are linear time. And then within here, another function. We don't know what this function is, but it's calling to another function outside of the funChallenge function. This is also being called how many times? Well, it depends on how big our input is. So once again, it's O of n. What about this? Let variable stranger equal to true. Again, another random assignment here, but this runs as many times as this loop happens. If input was 5, this will run 5 times. So again, this will be O of n. And then over here we have a++, which in JavaScript simply means a plus 1. So we're just incrementing the whatever the number a is at this time. So 53 will become 54. And then as we loop through it, it'll keep increasing by 1. 54, 55, 56. This, once again, runs O of n times. It depends how many times it runs by the input because, again, we're looping through it. And then finally, another thing that some people don't count, but just to keep it consistent, every single step that we do, return A. This runs just once. Every time funChallenge gets run, the return statement only runs once. All right, so we have all these big O notation. And now we're starting to think about how a function runs and how efficient a function is. If we actually calculate all of these, if we total all these up, we see that we have 1, 2, 3. So we have 3 steps plus O of n, O of n, O of n, O of n. So that means we have n plus n plus n. So that means we are running the calculation n plus n plus n plus n, which turns out to be 4n. So 3 plus 4n is our big O notation. There it is. Like I said before, when it comes to big O, don't get too hung up on, did I get this right? Because in an interview, you're not going to need to know this. But you are able to now think about how a function runs more deeply than just simply writing the code. As we progress through the videos, you're going to find out that this actually, at the end of the day, gets simplified to just O of n. And we're going to go through that and why that is. Now that we have a better understanding of how to calculate big O, let's look at another exercise that should be a little bit easier than the first one that we did. What would you say that the big O of this is? Well, if we go one by one, we see here that we have O of 1, again, O of 1. And you know what? If I keep typing this is going to get tiresome, so I'm just going to copy and paste. So O of 1 here, we're just assigning variables. And then we also see here that we have a for loop that is running based on the input. We don't know what that input is, but we can just assume that we're looping based on however long this input is. In which case, we're running each one of these O of n times, or whatever long the input is. So again, these are going to be run O of n and O of n times. And if we go down here, again, same thing. We don't know what the input is, but these are being run O of n times. And then finally, this last line is just run once. So it'll be O of 1. So looking at this function, another funChallenge function, we see that our O of n, our big O, is 1, 2, 3, 4. So we have 4 plus, because we're just adding up the steps here, we have O of n that's happening 1, 2, 3, 4, 5. So 5n. So the big O here is we have 4 constant times and then 5 things that we're doing n times, or however long the input is. All right, that wasn't so bad, was it, compared to the first time around? I think you're starting to get the hang of this. So let's dive into the next video. Let's start to figure out how we can simplify things for us so that we're not doing this mathematical step-by-step count. I'll see you in the next video. Bye-bye. Welcome back. Now, in the previous exercise and the exercise we just did, we see that we had to do a bit of calculation. It was kind of annoying where we had to add things up, then have this, plus 5n plus 4. In interviews, you're never going to do this. And you're asking yourself, Andre, why did you just teach me this? And you're right. But now you at least understand how big O gets calculated. But most of the time, when you go into interviews, there's these set of rules that you're going to follow, where you don't need to do this, and you can just take a look at this function and immediately say what type of big O it is. For example, this function actually just turns into O of n. This function, again, turns into just O of n. And this is a nifty little trick. When we talk about big O, in interviews, most of the time, you're only going to give one of these answers. You're most likely never going to actually calculate precisely O of 3n or O of 3n plus 2 plus 1. So how was I able to simplify our exercises and just say that they're On? And luckily for you, there are just several rules that we can follow when it comes to big O. And there's only 4 of them. By following these 4 rules, instead of doing those small little calculations that we've been doing up until this moment, you can just simplify your life so that big O becomes really, really easy to calculate. Let's tackle the first one. That is rule number 1, worst case. Let's talk about that in the next video. Welcome back. Let's talk about the very first rule when it comes to big O. That is worst case. When calculating big O, we always think about the worst case. What do I mean by that? Well, if we go back to Finding Nemo example. In the Find Nemo function, you may have been screaming at me while I was going through the function saying that, Andre, this is not efficient. What are you doing? Because if you look at this function, we're looping through the entire array to find Nemo. Remember how we had the everyone array with about 10 different characters from Finding Nemo? Well, Nemo was only the 1, 2, 3, 4th member on this array. And when we run this function, we found Nemo. But the funny thing is, this function ran 10 times, not 4 times. If I do a console log here, and I say running, and let's click this, we see that this function ran 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, we already found Nemo. All these runs are pretty wasteful. So we can make this function a little bit more efficient. In JavaScript, we can just have something called break. And again, different languages have different ways of exiting out of a loop if a condition is met. In our case, if we find Nemo, just break out of this loop. If I do this and click run, look at that. Once we found Nemo, we're done. We're not going to loop through the rest of the items. Congratulations, we just made our code a little bit more efficient. That's a good thing, right? Well, when it comes to big O, although this is important, and when you write good code, this is something that we want to do. In the big scheme of things, big O only cares about the worst case. What is the worst case here? Well, the worst case is that Nemo, instead of being the fourth item, is at the very end. So even if we have this break statement, we're still going to run this 10 times because Nemo at the end. Best case is if Nemo's at the very beginning and we only have to loop through it once. But worst case, we're still going to have to go through 10 loops. Still big O of n. So this is our very first rule. The very first rule is we always care about what is the worst case scenario, because when we talk about scalability, we can't just assume things are going well. Even though the find Nemo function might be O of 1 if Nemo is the very first item in the array, it doesn't matter. In the grand scheme of things, because we can't be certain of what the input is going to be, we're going to assume that O of big O is O of n, linear time. Again, if we're finding a yellow box and the yellow box is at the very end, we have to iterate through all the boxes. If the yellow box at the very beginning, you see that we don't have to iterate through these boxes. But big O doesn't really care. Even though this function, yes, is indeed more efficient, at the end of the day, when we talk about big O, we're talking about worst case. All right, I hope you got that point through. I feel like I've beaten it to a pulp, so you should be comfortable with it by now. Let's talk about the next rule in the next video. Welcome back. Let's look at rule number 2. That is, remove constants. Let's see what I mean. I've written here the most ridiculous function ever. The function is print first item, then first half, then say hi 100 times. Probably not the best named function ever, but as the name describes, all we're doing is we're going to console log the first item in the array, and then we're going to print the first half of the items. So I'm finding the middle index of the items. So I'm saying items.length divided by 2. And I use math.floor here in JavaScript as a way for us to make sure that we get a whole number. And we're going to say variable index is 0. I'm using a while loop here instead of a for loop. And I'm saying as long as middle index is greater than 0, I want you to console log the items. So that means console log the first half of the items. So if we had 10 items, I'm going to console log the first 5 items. And then I'm going to do another for loop and say I'm console logging hi 100 times. Pretty useless, I would say. Not a very useful function. What is the big O of this function? Well, looking over here, it's going to be big O of 1 over here. So we have 1 for just logging the first items. Then we have half of whatever the items is. So in our case is n divided by 2. Because even though we have a for loop or a while loop, we're only logging half the items every time. So we can just do n divided by 2. And then finally, we're doing a for loop. But again, this is a bit of a trick. We're not looping over the items array. We just have 100. No matter how big the items array is, this is going to be always 100. So I just say plus 100. It's another step. Because again, we're just adding each of the steps that we see here. So this is our big O for this function. But rule number 2 states we want to drop the constants. we simply are saying that we don't really care that this big O is actually n divided by 2 plus 101. Remember, in an interview, we only care about the things that we saw on the chart. Nothing specific like this. So this turns into 1, and this, even though it's divided by half, in the grand scheme of things, we only care about when it scales, when the inputs are getting larger and larger. So as n gets bigger and bigger, we don't care about adding an extra 100, because if n is 1,000,000, adding an extra 100 on there, another 100 steps, doesn't really matter. And same with dividing by 2. As n gets larger and larger, dividing by 2 has a decreasingly significant effect. So we drop the constants like this. So this becomes O of n plus 1. Okay, and because 1, if n was 1,000,000, is very insignificant, we can just drop this as well. This function just becomes O of n. What if we had another function that had, let's say, O of a plus 50? Or a of 50 with a ton of zeros. It doesn't really matter. We drop the constants. It's going to be O of a. What about this other situation? What if we have this function here, compress boxes twice, where this function actually has 2 for loops, where it does the same thing, but it's 2 for loops. So we have O of n in this for loop, and then O of n in this for loop. And because these are 2 separate steps, well, we add them together. So it becomes O of n plus O of n equals O of 2n. But again, in an interview, this doesn't really matter because we drop the constants. And if we drop the constants, what does this function equate to? Well, it's just O of n. To prove that I'm not lying to you, if we look at this function on our graph, we see that the elements, as the elements increase, we have 2 operations because we have 2 for loops. If we have 2 elements, in that case, we do 4 operations. If we have 3, then we do 1, 2, 3, 4, 5, 6. And you see how it increases. But at the end of the day, even though the line is steeper, we have a lot more operations to do. The way the line increases is still linear. And that's the key here. With big O, we don't really care about how steep the line is. We care about how the line moves as our inputs increase. Makes our lives a whole lot simpler, doesn't it? So remember, drop the constants. You're never going to really see numbers in big O notation. Most likely the notations that we've seen in the past before on our graph. Usually these, and the only time you see numbers is when you have O of 1, O of n squared, or O of 2 to the power of n. Which we'll get to later, don't worry. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about rule number 3. That is, different terms for inputs. And this is one of the trickiest parts of an interview that a lot of people make mistakes on. But once you understand it, it becomes really easy to spot. So let's look at an example. I have the exact same function we saw in the last video. Compress boxes twice. We have the boxes array. And we just have 2 loops here. I'm using the for each syntax in JavaScript. But we're just looping twice over the same array. And as I said before, the big O of this is going to be 2n. But because we drop the constants, it becomes O of n. But the third rule states that different terms for inputs. And what that means is, well, first of all, let me ask you a question. What if here I have boxes as the first parameter, and then we have boxes 2 as the second parameter? And maybe this second for loop actually loops over the second boxes. What happens here? What is the big O? And during an interview, a lot of people trip up and say that this is, well, still O of n. It's going to be O to n, drop the constants, O of n. Now, is this right? No, because the third rule states that different terms for inputs. And remember, boxes, the first one, and then the second one are two different inputs. One could be 100 items long, another one can be just one item. So this first for loop is going to depend on how big the first item or first input is. And then the second for loop depends on how big this one is. And n is just an arbitrary letter that we decided on. In this case, the big O of this function would be something like A for the first for loop, which is the first input, plus B. The big O of this function is actually A plus B, or n plus m, or boxes 1 plus boxes 2. So keep that in mind. Just because you see two for loops, one after another, doesn't mean that they're looping over the same items. Now, you might be asking yourself, Andre, what happens if these loops are nested? So far, we've only worked with loops that are one after another. What if this loop was inside of this loop? Well, let's get into the next video and talk about another common pattern we see with Big O, that is nested loops. One common interview question that you might get is something along the lines of log all pairs of array. Now, what does that actually mean? Well, if we had an array, let's just say boxes, and this array is just contains boxes numbered 1 through 5. Now, this array, if I want to log all pairs, it means that I want to log 1, 2, then 1, 3, then 1, 4, then 1, 5, then 2, 1, then 2, 2, 2, 3, 2, 4, 2, 5, so on and so forth. How will we go about doing that? And if you want, you can pause the video and try to attempt this problem yourself. Now, in this case, what we want to do is, well, we create a function and we'll say log all pairs of array that receives an array. Let's just say array, so we're descriptive here. And in here, we will do a for loop. So for let I equals 0. And we've done this before, so if I is less than the array.length, and we'll increment I. Now in here, we want to loop, so now in the first iteration of the for loop, we'll grab 1, but then we want to loop through the boxes again and log 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So we have another for loop, and this time we'll say let j equals 0 if we want to loop from the beginning, or I could even say 1 if we want to start off with 1, 2, because we're starting off at index of 1 right here. For now, we can just leave it at 0. And we'll say that as long as j is less than array.length, and we'll increment jj. And now finally in here, I can just say console.log I and j. Let's run this function and see what happens. Oh, I have to actually call this function. So let's do that. Log all pairs of array, and I'll give it the boxes array. Oh, and we want to make sure here that we're logging out the actual items and not the index of the array. So we'll just say array I here and the array j here. And just so you don't get confused with the numbers, maybe we'll change these into letters so that it's more obvious what we're doing. C, D, that's not D, that's D, and we'll say E. So if I click run here, we see that we're logging all pairs. AA, AB, AC, AD, keeps going until EE. You can see the log over here. What is the big O of this? And this is something that you're going to see a lot of in interviews. And a good rule of thumb is if you see nested loops, that means instead of having 2 for loops, one after another, where we use addition, when you see loops that are nested, we use multiplication. So this becomes O of n times O of n, which when we multiply them becomes O of n squared. O to the n to the power of 2. And that's a good rule of thumb. And if we go back to our graph, this function that we just created, and I'm using the ES5 syntax here instead of the for loops we did, this O of n squared is what we call quadratic time. That means every time the number of elements increase, so let's say we have 2 elements, we have 4 operations that we do. If we have 3 elements, this actually increases quadratically. That means instead of 4 operations, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have 3 elements to the power of 2. And you see here how the line is now bent and it increases, well, quite fast. If we go back to our big O notation or big O graph, we see that O of n squared, well, it's horrible, as in it's pretty slow. As the number of elements increases, the number of operations increases significantly. And a lot of interview questions are questions that ask you to solve a problem that initially is O of n squared and make it faster by perhaps making it into something that is a bit low over here. That is bad, fair, good, excellent, but definitely not horrible. If we go back to our rule number 3 that we were discussing, different terms for inputs. Well, going back to that example we had in the previous video, remember this? Well, we said O of A plus B because we had 2 different arrays or inputs. Now, if these loops were actually nested and they're not one after another, the big O would have been O of A times B. And that is rule number 3. Making sure to know that we have different arrays, that means different notation for each array because we don't know the lengths. And an easy rule of thumb is any step that happens in the same indentation, so one after another, you add. And anything that happens with indentation that is nested, you multiply. So again, different inputs should have different variables. Let's move on to the last rule in the next video. Oh, we can feel the end, almost. We're in rule number 4, the final rule in our rulebook. Drop non-dominants, or drop non-dominant terms. What do we mean? Let's have a look. Let's say we have a function, again, with a really long name that says print all numbers, then all pair sums. Maybe not the best name for a function. We can probably work on the readability here, but let's see what this function does. Well, this function takes numbers, and these numbers variable, we're going to loop over them with a for each loop. So again, just looping over and logging out the numbers. And then we have another step, which should remind you that's probably an addition that we're doing. We're adding another step. And in here, we're summing the pair sums. That is, we're adding each number one after another. Let's show you with a little bit of a demo here. If, let's say, we create, actually, we'll just print numbers. And in here, for the numbers, let's just give it an array of 1, 2, 3, 4, 5. If I click run here, we see that these are the numbers 1, 2, 3, 4, 5. Because this is the step, we're just logging it out, nothing too difficult. And these are their sums. All we're doing is adding 1 with 1, then 1 with 2, which equals 3, 1 with 3, which equals 4, 1 with 4, which equals 5, and 1 and 5, which equals 6. And then we move on to the next loop, which is 2 and 1, which equals 3, 2 and 2, which equals 4, and it keeps going on and on and on. So we see the loops that we've done here. And problems like this is something we're going to do later on in the course. Right now, we're just worried about big O. What do you think the big O notation here is? Well, once again, if we do O of the first part is the for loop. So we can say that there's O of n. And then the second part, which again is another step. So we're going to say add plus. This one has 2 for loops nested. So that means O to the power of 2. All right, so that's our big O notation. But rule number 4 states that we want to drop the non-dominant terms. That means we care about the most important term. In this case, we actually drop the n and just have n to the power of 2 because as the input increases, the size of n to the power of 2 is way more important than the n. So we always just keep the dominant term. Let me give you another example. What if we had a function that had a big O of, let's say, x to the power of 2, and then we'll say that it has 3x plus 1000, and maybe we'll say plus x divided by 2. All right, that's really, really confusing. That's math. We're not gonna want to deal with that too much. How do we simplify this based on the drop non-dominant terms? The 4th rule states that, again, we worry about the most important dominant term. Because x to the power of 2 is the most significant. That is, if x is 5, 5 to the power of 2 is 25. 5 times 3 is 15. This is 100. And 5 divided by 2 is 2.5. In this case, the dominant term is 100. But remember, with big O, we're worried about scale. And as things go larger and larger and larger. So when this becomes 5,000, well, 5,000 to the power of 2, or 500 to the power of 2, that's 250,000, if I did the math right. 3 times 500 is only 1,500. 100 is now insignificant, and 500 divided by 2 is 250. You see how this has grown significantly more? Again, because we're only worried about scale here, we drop everything else and we can just ignore it completely, and this becomes x to the power of 2. How nice is that? Just makes things so much simpler. So there you have it. We have now a way to simplify everything. If we go back to our past examples, remember this one? Remember this one? It now makes sense why we've just said big O of n. Because We don't care about the insignificant items, only the most important ones. And same with this one. By the way, a fun little note here. If we had another loop inside of these two loops, well, this would become O to the power of x cubed, and cubed doesn't really matter what we have, but it's going to be to the power of 3 because we have 3 nested layers. And you can keep going. You can have to the power of 4, to the power of 5. But here's the thing. If you have 3 nested loops, 99.99% of the time, that's usually a bad idea. It scales really, really badly, and most likely you're doing something wrong. And there you have it. We've gone over the 4 rules. And with this in mind, we're going to take a look at the cheat sheet that I've prepared for you. So from now on, instead of having to calculate everything and really look at every single detail of a function, you can right away figure out what the big O is, or what the time complexity of a function is. Now, I've created for you a nice big O cheat sheet. Although we've taken a lot of time to go through everything, at the end of the day, when it comes to preparing for an interview, this is pretty much all you need to know. And you can use this to review some of the topics we've covered, as well as what we're going to cover for future sections. We see here that the big O's, they're mainly these ones over here. Now, we haven't gone through everything. We've gone through constant time, but we haven't gone through something like O log n, or On log n, or O to the 2 to the power of n, or even this one with the exclamation mark. I wonder what that is. Well, we're going to get into that. But the reason I haven't talked about them yet is because they're going to come up when we talk about data structures and algorithms. These commented out big O notations are very specific for certain algorithms and data structures to optimize code. So we're going to get into that when we talk about these topics because they'll make more sense to you. Such as O log n is used a lot when it comes to searching algorithms. Or On log n is used a lot when it comes to sorting algorithms. And something like O2 to the power of n comes into play when we talk about recursive algorithms. So again, don't get overwhelmed. We've talked about these 3 major ones, and we're going to come back to the rest throughout the course. Now, when it comes to big O's, I want you to keep in mind 2 things. When you're iterating through half a collection, it's still O to the power of, or O to the n. Remember, On divided by 2, it's still, at the end of the day, On. Remember our rule book. And again, another trick that often comes up in interviews is that 2 separate collections should be A plus B, or if they're nested, A times B. So 2 separate inputs should have 2 separate variables in big O notation. And just to keep in mind what causes time in a function, because that's what we're measuring right now, well, operations, comparisons, looping, we know that takes a while, and things like outside function calls when you have a function inside of a function. And then finally, we talked about our rule book. Always, big O measures the worst case. We want to remove constants. We want to have different inputs that have different variables. So O, A plus B, A and B are arrays. If they're nested, are A times B. Again, something that we've mentioned up here. The easy way to remember this is addition for steps in order and multiplication for nested steps. And then finally, rule 4 is to drop non-dominant terms. Pretty simple, right? I'm going to bring this big O cheat sheet back when we start talking and filling our gaps with the rest of the big O notation. But for now, let's get into the next lesson. Welcome back. You may have noticed something while talking about big O. Scalable means we worry about large inputs. What does the end of the graph look like? So if our function is only worried about really small inputs, or we know that our inputs are only going to be, let's say, an array of 5 items, big O won't matter as much, does it? Because Over here, if the elements are small, all these lines are kind of bunched up together. They're all the same. But is that real life? No, because as humans, we tend to think in here and now. We tend to think that, oh, our website's only going to have 100 users. That's it. But what if that user base grows? What if our inputs grow? We never know. When we write code, we want to write code that can scale so that we don't have to constantly go back and fix things. Or when things get out of hand, the code breaks. And that's why Big O is so important. To write scalable code means thinking outside of just this small little section over here. It means thinking long term, thinking big about your code and what could happen in the future. Now, you're thinking to yourself right now, hey, Andre, I feel like I just learned a whole bunch of theory and no practical information. Andre, I want to know exactly how I can use this in my day-to-day life as a coder. I'm kind of getting bored here. Well, with this newfound knowledge, you're going to look at code differently now, right? Let's have a look. You see, now, when we look at methods that we get in a language, such as methods in an array, when it comes to JavaScript, we have things like push, pop, shift, unshift. You see, all these methods, which are functions, have a cost associated with them, a big O cost. For example, when it comes to arrays, when we search for an item, or when we access the first item in an array, for example, it's O of 1. But when we use something like unshift, well, it actually turns out to be O of n. And why that is, we're going to get into when we talk about the data structure array in the data structure section. But you're going to start to see for the rest of this course how we use Big O to measure why one data structure might be better than others. Why should we use an array instead of, let's say, an object? Maybe object has better functions that we need for our data. This graph that we've talked about up until now is actually part of BigOCheatSheet.com. And if we scroll down here, you'll see that each data structure, that is an array, and in this case, objects on this table is a hash table. Again, something that we're going to cover in the data structure section. But we see that we have different Big O notation for different data structure. And some data structures have really good search Big O. Some have insertion, some have deletion. And you can see here that there's different pros and cons to each of these data structures. As you'll find out in this course, data structures are simply ways to store data, and algorithms are simply functions or ways to use data structures to write our programs. Remember our instructions for machines, for our computers. And great programmers have this knowledge where they pick the right data structure, the right algorithms to write good programs. Remember our two rules of good code: readable and scalable. And what we've learned is the foundation for us to make a decision of which data structure is going to be best when we get into the data structure section, because we're going to know, oh, arrays allows us to access at O and 1 constant time. But when it comes to searching through an array, it's going to give us linear time versus perhaps maybe an object. So behind the scenes, even though this section may be a little bit theoretical and boring, what we've just learned is going to lay the foundation for the rest of the course for us to be able to write good code. For the rest of the sections, we're going to use Big O to see what is a good solution to a problem and what is a bad solution to a problem. And most interviews have this core concept. What's the right data structure? What's the right algorithm to write good programs? Google hires engineers and developers that know this because they have a lot of scale that they have to think about, a lot of inputs. And people that know how to handle these programs are the ones that are going to be able to build great programs. I'll see you in the next one. Bye-bye. Let's quickly talk about a big O notation that you're most likely not going to encounter. And if you're writing any code that has this big O notation, you're definitely doing something wrong. It's the most expensive one. It's the steepest of them all. And this is called factorial time, or as I'd like to call it, the oh no. We're not even going to do a demonstration on this because you're just not going to encounter it. I just want to show you that it exists. With O n factorial, and this is a mathematical notation with an exclamation mark. You can search for it and see how it works underneath the hood. But with this, it means that we're adding a nested loop for every input that we have. Yeah, that sounds pretty terrible, doesn't it? Again, just to keep in mind and to get this out of the way, O n factorial, probably never going to see it, but it's there, and it kind of looks cool. So we can cross another one off our cheat sheet. O n factorial, you're adding a loop for every element that you're iterating over. Yeah, it's an expensive one. I'm not going to see it much. So I'll see you in the next video. Bye-bye. What is good code? By this point, you should be able to talk a little bit, especially about scalable, right? I mean, readable, we're going to talk about in the next section, but scalable, we understood was big O, right? Well, here's the thing. Don't hate me, but I may have slightly lied or simplified things, but not that much, so don't worry. We're going to build on that. When I say scalable, there's actually two things that we want to consider as engineers. One is speed. That's what we've been talking about up until now. How fast is our runtime on the code? How much time does it take for a function to run? How many operations does it cost? Well, there's another aspect when it comes to machines. Two valuable resources. One is the time and speed of our code, and the other one is memory. You see, computers have limited memory. Back in the day when computers were just being born, memory was very, very expensive. We only had a little bit of it. And as time has gone on, we have more and more memory, but it's not infinite. Our computers run based on speed, which is usually dictated by the CPU, and memory, based on how much memory, such as RAM and random access memory, the computer has. And those are two valuable resources. So how can we talk about memory? We've talked about speed. What about memory? And the good news is that memory is fairly simple, not as complicated as speed, and it won't take as long to learn as much as we have about speed. Right now, which code is best can be answered with the 3 pillars of code, something that I want you to take with you for the rest of your career, and something that's going to grow you as an engineer, because from now on, when you write code, you're going to have these 3 things in mind. One is you're going to write readable, clean code that others can read, that is maintainable. The other one is speed. The type of code that we call time complexity has a big O time complexity that is efficient. It scales well. But we're going to talk quickly about this third pillar, and that is memory. What's the memory usage of code? If it uses a lot of memory, that's not good. We might have limited memory on our machine. With this one, we use big O once again to talk about space complexity. The same notation, but different topic. One is space, the other one is time. One is speed, the other one is memory. I'm going to give you a quick little preview. Most programming code solution, there's usually a trade-off between speed and memory. You want things to go faster? Well, then you might have to sacrifice more memory. You want less memory? Well, then you might have to sacrifice with increased speed. Let's get into the nitty-gritty of how we measure space complexity. When a program executes, it has 2 ways to remember things. the heap and the stack. The heap is usually where we store variables that we assign values to. And the stack is usually where we keep track of our function calls. Sometimes we want to optimize for using less memory instead of using less time. Talking about memory or space complexity is very similar to talking about the time cost. We simply look at the total size relative to the size of the input and see how many new variables or new memory we're allocating, how much memory is being used. So let's look at an example. Up to this point, we've talked about time complexity and how if we want to compress, let's say some boxes, we just talked about how fast and how many operations this would take. But in real life, there's this other factor of memory. And we have this pink little box of how much this function can take, how much input it's able to take. For example, if we had a ton of boxes that we have to create to run this function, well, it has limited capacity and it might overflow. By the way, things like stack overflow is something we're going to be talking about and how it's an issue when it comes to memory. Something we'll cover when we get into recursion. What causes this space complexity? Well, luckily for you, I added this to our cheat sheet. What causes space complexity? Well, adding variables, adding data structures like arrays, objects, hash tables, again, things we'll talk about, function calls, and allocations. We don't need this period. But let's actually code something and show you an example. In the next video, we'll go through some space complexity exercises and figure out how we can give big O notation to the subject. Welcome back. Let's talk about space complexity. What if I have a function that has the name of Boo, and all it does is it takes an input, and within this input, it's going to simply have a loop that we've seen before. And this loop, let's make sure that I do this properly. Let's say that n.length, and we'll say I++. And this function is a really useless function that just simply logs out console.log Boo. Scary function. So now in here, if we just run the function and just give it an input of, let's say, 1, 2, 3, 4, 5, and run it, well, we have Boo running 5 times. And we know that the space complexity of this function, or time complexity of this function, is O(n). But when it comes to space complexity, let's think about this. What is the space complexity of this? Now, try to guess before I go into the topic. The one gotcha when it comes to space complexity is that when we talk about space complexity, we're talking about additional space. So we don't include space taken up by the inputs. So we don't really care how big the input is. I mean, we do care, but when it comes to this function, we don't really have a control over what sort of input it receives. We only have control of what happens inside of this function. So within this function, are we adding any space? Well, not really. The only thing we're really doing is we're creating this let I equals 0 variable. And that's it. Other than that, we're not really adding any more memory. So this function has a space complexity of O(1). Nice and simple. But what if we have a different function? What if we have something like this? This time we'll have a function that says array of, I'm going to give it another terrible name, high and times. God, that's a terrible name. But let's say that this function takes, again, an input. And within here, we're going to create a new variable. We're going to say let high array is going to equal an empty array. And within here, we're going to have a loop. I'm just going to copy this for now so I don't have to bore you with my typing. And in here, I'm going to simply say high array in the index. So as we're looping, we're going to fill it up with high. And we're going to return this array, high array. All we're doing is we're creating a new array. And for the number of items in our input, we're going to just fill up high array with repeatedly high string. So if I do this again and I say array of high and times, and I give it, let's say we'll give it, and you know what? Instead of length here, let's just leave it as a number. So I'm going to say n, and I'll say 6 times. So if I run this code, we see that even though we have the boo 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 over here from the beginning, the other function, array of high and times, returns us a new array with 6 items, and each item just simply says high. What is the space complexity of this? Well, this should give you a hint. Remember our cheat sheet. Variables, data structures, function calls, allocations, those things take space. And in our case, we created variables in our loop, variable I equals 0. But we've also created data structures, right? We created a new array. So now if we go back, we see that in here, we've created a new array and we fill this array with n loops. And again, because of our rules when it comes to big O, we ignore the constant time, let I equals 0 space. And instead, this becomes O of n, because we're creating a new data structure and adding memory, so each item is an additional memory space on our computers n times. And you know what? That's pretty much it when it comes to space complexity. I think you're getting the idea, and we'll get a little bit more into it when we talk about recursion. But when it comes to space complexity, you're either adding additional memory that you need to use, and that's sometimes a big concern, and sometimes there isn't. And something that comes up a lot in interviews, and something that we'll talk about in the next section. That is, sometimes there's a trade-off between saving time and saving space. So you have to decide which one you're optimizing for. Let's get into some fun examples based on what we've just learned in the next video. See you in that one. Bye-bye. All right, let's do a fun exercise to show you that you've actually just become a better engineer. Let's have a situation. Let's say you're working at Twitter. And I hope everybody knows Twitter here. If you're working at Twitter and your boss asked you to build a feature, perhaps a feature that allows anybody to click a button next to their name and retrieve their most recent tweet and their oldest tweet. So that is their very first tweet and their very latest tweet. Based on Big O notation and what we know about Big O notation, what can we assume about this problem? Well, without coding anything, we know that we have to find first and then find nth, or whatever the last item is. Now, we don't know how the tweets are stored in our database or whichever way Twitter organizes these things. But based on how they are stored, we might be able to just grab, let's say the tweets were in an array. So let's say const array, and we'll have an array of tweets. And let's just say we have 3 tweets here. There you go. Just 3 simple tweets. We'll say that this one is the oldest and this one is the most recent. If we have an array here, we know that it's going to take us, if the tweets are stored in an array, it's going to take us, well, if we go array 0, we get the oldest tweet. And if we go array dot length -1, we get the 3 minus 1, so that is 2. So that is 0, 1, 2. This is going to be 2. We're going to get Teddy, the most recent tweet. And because of the way arrays work, we know that both of these operations will be O one time. And this one will also be O 1, or constant time. So a total of O2 operation, but we again use our rule book and simplify it to constant time. So that's great. We build a nice little simple Twitter application and we can get that information very easily. But now our boss comes back to us and say, hey, I want you to compare the dates of tweets. So I want you to look at every tweet. Now, within each array, there's an object. With each tweet, now we have, and this person does not tweet a lot, 3 tweets in 6 years, but now we have to compare each tweet with all the other tweets and compare their dates. What is the big O of this operation? Well, because we're comparing each item in the array with the other, this should sound familiar, we're doing nested loops. So this is going to take O and square time, at least with what we know right now. So we know that this is going to take a lot. And if it's a person that has a lot of tweets, a lot of inputs in the array, this operation might cost us a lot of money at Twitter. So you might want to tell your boss, we might have an issue here. We might need to do something else. Perhaps store this information in a better format or do something different with our program in order to avoid something that might be inefficient. It might be expensive for the company. And just by thinking like this now, you have this ability to think long term, think scalable code. By the way, as a fun one, what happens if I ask you, what is the operation and what's going to cost us if I have a string and I do dot length here? In JavaScript, that just means what is the length of our string? That is 20. That means we have 20 items in the string. What do you think the big O notation of this is? And this is a bit of a trick question and something that you might get asked in an interview, because the answer to this is depends. It depends on the language that you're working with. We need to know how the method works on the string here, and that's built into JavaScript. And you'll have a different built-in method for your language. Based on how the language was built, this dot length might go one by one and iterate over each letter and count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way until 20. But JavaScript actually has dot length property built in to each string. So for JavaScript, this dot length property is just a simple lookup. It's not a function. We're not running this function to calculate things. Instead, it's simply a property of an object. And because of that, And again, if you're not super familiar with JavaScript, this may be a little bit confusing, but don't stress out. The idea is that this operation in JavaScript is O constant time. But without knowing how your language works, you don't know how this property might work. How perhaps if you had a method, how that might work. But now you have a powerful foundation, powerful pillar to start thinking about code in a different way. Start looking at space and time as something that are valuable to us as engineers, as resources that we must be careful. We don't have infinite amount of resources. We have to be careful when we code how we use up these resources. And that alone makes you a better engineer. I'll see you in the next video. Bye-bye. Welcome back. I just wanted to show you a quick video, especially for those that are familiar with JavaScript, that there are many, many ways to do loops in JavaScript. And same with other languages as well. There's many ways to do these loops. So I just want to show you some quick ones that you might see throughout the course, just so you're familiar with them. For example, the find Nemo function that has a for loop can also be written with something like a for each function. So I can say const find Nemo 2 takes in an array. And we can say that for each array, for each, which is pretty much the exact same thing as a for loop, but requires you to not have to type this entire thing. For each item in the array, so we'll say I, we're going to say if I equals Nemo, because in this case with for each, we're not taking the index, we're taking the item in the array. So maybe we could just say fish in here, just so it's more, or it makes more sense. And if that is the case, we'll just console.log found Nemo. Again, that is the same thing as this. For each just allows us to simplify things a little bit. There's also another way that we can do this in JavaScript with the for of loop. If we just copy this code and do find Nemo 3, this time the array that we're going to take, we're going to say, instead of the for each, this time we're going to say for let I of array. And again, this gives us the same thing, the I, or we can just say fish here, just so it's more clear, is equal to Nemo. We're going to say found Nemo. And if we run these functions, let's make sure that they both work. So find Nemo 2, find Nemo 3, and we also run find Nemo. If I click run, and I don't need the bracket for this one. If I click run, we see that we found Nemo all 3 times. Different ways of solving this problem. All of them are using loops, but you can see some are more readable than others. And that's something that we've encountered before, right? Remember, a good code means something that is scalable, but also something that is readable. Depending on your situation, and something we'll get into later on, how maintainable and how others on your team can understand this code, there's different ways of doing things so that it's easier to work with. But I hope that if you see this syntax throughout this course, you at least are familiar that at the end of the day, all we're doing is just loops. I'll see you in the next one. Bye-bye. Big O says, which function, algorithm, or code is best? We learned that when it comes to good code, we're concerned about readability and scalability. And Big O allows us to measure the idea of scalable code. And why do we care? It's because there is no such thing as a free lunch. You save time and money for a company, you're a superstar. Knowing how much time your code takes, How much memory it uses is very, very critical. Those are expensive things for a company or a product. Now, Big O is a very important concept that you won't find in your day-to-day job, but it's something that should always be in the back of your mind. And good developers and engineers always have this knowledge. That is why it is such a popular topic during interviews. Big O is used to describe how efficient we can run our code. It saves companies a lot of money if people they hire know how to write efficient code. And in this section, we learned about the idea of time complexity and space complexity, how we can use Big O to measure both things, but each one is a trade-off between the other. And Big O describes the upper bound of our estimates. We're always looking at the worst case scenario. We want to be pessimistic and say, what is the worst case scenario here with our code so we can be prepared when the time comes? Now, time complexity and space complexity. Time is how long it takes the algorithm to run, and space is the memory that is required by the algorithm. The important thing that we learned here is that Big O is about how you can scale. It doesn't necessarily mean that O(n) is better than O(n) squared, because scalability wasn't the only factor, right? Readability is something that we were concerned with as well. Sometimes readability maybe matters more than scalability. Maybe time complexity is less important than space complexity. And that's something that you want to be careful of now with this newfound knowledge. Premature optimization can be the root of all evil. It's a famous quote that a lot of developers know. Sometimes optimizing for time or space can negatively impact the readability of code. So if you're working at a young startup, for example, it might be more important for you to write code that's easy to ship and perhaps easy to understand later. Perhaps not take as much time to write the code and think about the code and its implications for long term, because maybe the startup has limited budget and needs things done fast. That doesn't mean startups don't care about Big O analysis. A great engineer at a startup or at a big company knows how to strike the right balance between runtime, space, and of course, readability. The thing to keep in mind is that data needs to be sufficiently big to talk about Big O. It's about scaling. If your function is linear time, but the input is always, let's say, 7 items, then the linear time algorithm might be better than the constant time algorithm. So it really depends on your situation. I introduced Big O here because we're going to be using it throughout this course. And as we learn more about data structures and algorithms, we're going to learn more about Big O and some other things we saw in this graph that we haven't talked about. But I hope you now look at a code differently, and you had a few aha moments throughout this section. It's certainly my favorite section and a great topic that really made me a better engineer once I learned this topic. So I hope it did for you as well. At the end of this all, you have a way to look at code differently. And when someone says, hey, how good is my code? You have a nice new way of looking at things and measuring things. I'll see you in the next one. Bye-bye. All right. So we have an idea of how to increase our percentage of odds of getting an interview. We also learned about Big O notation and how we can use it to look at our code and analyze whether it is efficient or not. Using our knowledge up until now, let's move to another important topic. At the end of the day, an interview is a way for the company to find out, can you solve problems that the company or employer has? Because if you're able to solve their problems, then you're valuable and you will produce more value to them than the salary that they're paying you. That is what a technical interview tries to answer. Now, we can be smart and strategic about where we apply and how we apply to a company, and we learned about that in the previous sections. But here comes the big challenge. You got an interview. What do you do? Over the next couple of sections, we're going to tackle this question and get you as prepared as possible for the coding interview. And we're going to get very technical. I know up until now we haven't seen that much code, but we're going to get into the nitty-gritty details over the next couple of sections. But before we dive into coding problems, data structures and algorithms and all of these fun coding details, we must first understand this one principle: how to solve problems. You see, if we know every single algorithm in the world, inside and out, you know all the data structures, you're the best coder in the world, well, it doesn't guarantee that you will succeed in a technical interview. This section is meant to prepare you so that you have the foundation laid out, so that after this, all you need to succeed in the technical interview is the actual coding aspects of the questions. You see, it's not the smartest interviewer that gets hired most of the time. It's the interviewer that is able to answer this fundamental question. Will you solve the company's problem? If you're a genius, but you can't talk to people, you don't work well with others, or you write ugly code that people don't understand, or you can't communicate a solution to a problem, then you won't get a job. You see, it's not necessarily about the solution to a problem in a coding interview. It's about the thought process and knowing the trade-offs between data structures and algorithms, space and time complexity. Just like in real-life coding, you don't memorize things. You have to deeply understand them. Understand the trade-offs. So that's what we're doing here. I know I'm taking a long time to get to my points, but we're trying to build the fundamentals before we dive in really deep so we understand the why of each thing. We're building this foundation by first understanding the big O, which we did in the previous section, and then learning how to solve these problems. In this section, I'm going to show you step by step what we need to do to solve problems in a way that companies really like, so that you succeed in this coding interview. We're going to look at some sample coding interviews from Google and see what they did and what is the ideal process to ace this interview. So that once we have these foundations, we can use data structures and algorithms to solve our problems. Because the interview isn't about your ability to memorize data structures and algorithms. Most people make that mistake. And interviewers can detect right away who actually knows these things versus just memorizing them the week before the interview. So, how can you ace the coding interview? In this section, we're going to talk about the technical interviews and how to succeed in them. I'm going to show you what a successful interview at Google looks like, and then break everything down step by step as to what you need to do. I will also give you a nice little cheat sheet to summarize everything in this section so that you can always view it before an interview. At the end, we're going to solve a coding problem ourselves, just like you would in an interview, and analyze different solutions to that problem based on what we have learned up until now. We're going to figure out the best way to solve the problem, but also analyzing different big O solutions when it comes to space and time. By the end of this section, you're going to have a big aha moment. I guarantee it, where we're going to take everything we've learned up until now into our data structures and algorithm sections to really understand the trade-offs. Let's get started, shall we? So what are companies looking for? Most people tend to think it's just coding skills, but as you can see here, there's actually 4 things that they're looking for. One is analytic skills. That is, how can you think through a problem and analyze things? And when you're coding during an interview, they want to hear your thought process and how you go from not knowing the answer to solving the problem. They're also looking at coding skills, which is, do you code well? Is your code clean, well organized, readable? They also want to obviously know their technical skills or technical knowledge. That is, do you know the fundamentals? Did you just memorize things? Or do you understand the pros and cons of different solutions. And then finally, your communication skills. Does your personality match the company's personality? Can you communicate well with others, with the team? Most likely you won't be working by yourself. You're working with others, with other teams, with bosses, with managers. And they want to know whether you're the type of person that's going to fit well and work well within the company. Again, most people get hung up on the idea of learning every single algorithm, data structure, doing 1,000 problems to practice before an interview. And these are important. But in most companies, you won't actually need to know how to write a binary search tree or write a sorting algorithm from scratch. I mean, we're going to go through that in this course, but most of the time, you learn it on the go, on the job, when you actually need it. And let's be honest, as engineers, we know that most of the time, when a problem presents itself, we're good at searching the web on Google for answers. Not a single one of us has everything memorized in our head. Companies know this. They're not dumb. What they're looking for are people who know how to look for answers. And they want to know that you know your data structures and algorithms, and you know of their existence. That's the key. They want to know when you should use a certain data structure over the other. Why should we use a certain algorithm over another? At the end of the day, companies want smart people. They want people that can solve problems that they cannot solve themselves because that's what they're paying you. And having worked at companies and also hiring people, it's surprisingly hard to find people that can solve problems themselves without holding their hand or walking them through a problem entirely. So moving forward, I ask of you to just do this one simple thing. Do all the exercises in the course, pause the videos if you need to, rewatch the videos if you need to. You need to understand the why of doing things. Why are we learning this? Why is this the answer to the problem? Why is this answer better than the other? Again, don't worry, we're going to practice this muscle throughout. Okay, let's dive into the next video to see what we're going to learn. I'll see you in the next video. Bye-bye. In order to solve coding problems, we need to learn these data structures and these algorithms. It doesn't look that bad, does it? Here's the big secret. There are a lot more data structures than this, and a lot more algorithms than this. But just like when you learn a new language, you don't read through the dictionary and learn every single word in that dictionary and that language. Instead, you focus on being able to communicate with others. You only focus on things that are being used most of the time. And when it comes to data structures and algorithms, these are what you're going to get asked on in interviews because these are the ones that get used the most. And 90% of the time to solve a really complex problem, you're only using these things. Doesn't look that bad, does it? All you need is the baseline skills. And companies just want to know that you've prepared for the interview and can succeed within their system. A lot of people complain about coding interviews or whiteboard interviews and how useless they are because they never use some of these algorithms or data structure in their day-to-day job. But they're just a way to weed out people that aren't willing to work hard. Look at this as an advantage. Not many people work on their interview questions. You're going to work harder than 99% of the people out there because you know that getting a good job will have a big impact on your life. And I mean, that's why you're taking the course. And as you see here, the good news is that it's not as hard as you think. You just have to put your time and effort into the right things. As long as we learn our right data structures, when and why to use them, how to implement them, how to solve problems with them, and same with algorithms, and we combine it with our cheat sheet that I'll create for you, when we compare our code that is readable, that is memory efficient, and time efficient, using Big O. Between these two, that's all interviews are. That's all coding interviews ask for. If we go back to our outline of the course, we're now getting into the technical interview section. And when I click over here, it's going to look overwhelming at first. And we're going to go over this diagram so it all makes sense. We're going to talk about different data structures that we have. Let's zoom in a bit here. You can see we're going to talk about arrays, trees, stacks, and graphs, and a lot more. We're going to talk about the big O of each one of these data structures. We're going to talk about different algorithms, when to use what. And like I said, this is going to look overwhelming at first, but we're going to go through this step by step so that at the end, all of this makes sense to you. We're also going to use the cheat sheet right over here to help us solve these coding problems. Now, in this cheat sheet, we've already covered the 3 pillars of good code. We already talked about what skills the interviewer is looking for, but we haven't talked about this part. So let's start with this section in the next video. Welcome back. We're going to do a fun little exercise here. Now, instead of me just reading off what I wrote, I have a little ask for you. You're going to use this cheat sheet and look at the step-by-step through a problem, which is a 15-step guide of what you should do when you're in a coding interview to solve a problem. And I want you to use this as you watch a little video. Now, this video is actually produced by Google, and it demonstrates, it's 24 minutes, so it's a little bit long, but it demonstrates how you should answer a coding interview. And in my opinion, this is the best coding interview that I've ever seen. Now, I want you to watch this and keep in mind that because we haven't learned data structures and algorithms yet, this is going to be quite difficult for you to understand. And that's the goal here. When you watch this, it's going to be really, really hard to follow the actual coding, maybe some of the language that they use. I believe they're writing the code in C++, so if you don't know C++, it might be difficult, but that's not the point. The point for you here is to watch this video, but also read the step-by-step through a problem and see how the interviewee, in this case, in this video, follows these steps. And these steps are what you're going to do when you solve a problem in a coding interview. The fun thing is that at the end of this course, we're going to revisit this video. And you're going to notice a difference from this very first time you're going to watch this video to the very end, where what the interviewee does becomes second nature. You understand what they're coding in, what they're doing to solve the problem, and all these little steps, so that I succeed if you completely get this video and you understand how to run a successful interview at a company like Google or any large company, or maybe even startup, depending on what you like. So to get started, I'll be right back. You go watch this video, you follow the 15 steps, and after this, we're going to do a little problem of our own and follow the guide, the 15-step guide to solve our own little problem. I'll see you in that one. Bye-bye. Welcome back. By this point, you should be familiar with how a typical successful coding interview should look like, especially how to solve a problem in front of an interviewer. And we're going to do a fun little exercise here. An interviewer just asked us a question. And this is the question right here. Given 2 arrays, create a function that lets a user know, true or false, whether these 2 arrays contain any common items. For example, if we had 2 arrays here, one containing A, B, C, X, and the other one Z, Y, and I, it would return false because there's nothing common between these 2 arrays. However, in this example, array 1 and array 2 both contain X. And because they have a common item, it should return true. So an interviewer just asked you this question. How will we go about solving it? Well, let's go step by step through our little guide. When the interviewer says the question, write down the key points at the top. Make sure you have all the details. Show how organized you are. Well, in this case, I've kind of done this for you over here. Ideally, you would write this out as you are coding and make sure that you show the interviewer, okay, if I had this example, it should return false. If I had this example, it should return true. Now, let's say the interviewer only gave you these points and no other information. At least now you have an idea of what our problem is going to look at and whether we want to return false or true. But we have two things that we want to do with our function. One is we have two parameters, and this function is going to return true or false. Now, in the second point, make sure you double check. What are the inputs? What are the outputs? Well, we've kind of already done that, and we've confirmed with our interviewer that we have two inputs, which are arrays. We can even ask the interviewer that, are they always going to be arrays? Is it possible that the input might not be arrays? Maybe an object, maybe a string. And we can confirm with the interviewer what those cases are. In our case, let's say that the interviewer says that these two parameters are always going to be arrays. And we always want to return true or false. And number two is really important here because we don't ever want to jump straight into coding. Even if you think you know the answer or you've seen this problem before, you know exactly what to do, don't jump straight into coding. First, explain your approach, like I'm doing here, talking it out. Because if there are any problems with your approach or with your understanding of the question, your interviewer is going to often point them out to you here before jumping straight in and looking at your code and saying that, no, this is wrong. This way, both you and the interviewer know exactly what the steps are that you need to follow. Now, let's look at point number 3 here. What is the most important value of the problem? Do you have time, space, and memory to run this function? What is the main goal? Now, because this is a simple question, we might want to ask the interviewer how large this array is going to get. Because if the interviewer says the array is never going to be more than 5 items, well, then maybe we don't have to worry about big O or time complexity or space complexity as much. And then you can ask the interviewer, is our goal here to be as efficient as possible with our function? What's more important to us? Is time complexity more important or is space complexity more important? Maybe the interviewer might tell you that we just want the most efficient function that you can come up with, assuming that the array can get very, very large. So let's say in here we have 2 parameters, arrays that have no size limit. So these arrays can get really, really big. And in terms of returning true or false, that's all we want. We just want a Boolean return. Now, number 4, don't be annoying when asking too many questions. And we're kind of getting to that territory where we've asked a lot of questions to the interviewer and we kind of have an idea of what we want to do. We can keep asking them questions, but remember, you usually have a time limit. You don't want to keep bothering them, annoying them, and just asking them all these small little questions before we start coding. Keep time in mind. And I think at this point, we have an information that we can move on with our assumption to start solving the problem. So, number 5, start with the naive brute force approach. First thing that comes into mind, it shows that you're able to think well and critically. And you don't even need to write this code, just speak about it. This is always a case when an interviewer asks you a question. They usually have an easy solution that we call the brute force, which is not the most efficient, but usually is the easiest one or the first one that comes up in mind. So in our case, if we look at this, during an interview with a time limit, you might say, this looks like a nested loop where we're comparing A with Z and then A with Y, then A with I, and then we go to B with Z, B with Y, B with I, and then so on and so forth. So immediately this looks like we're comparing 2 different arrays, and we're going to have 2 for loops, one nested on top of each other. And right away we know that that's a big O, which we've talked about, of O n squared. Most likely during an interview, nested for loops is something that we want to avoid. Just telling the interviewer this solution, even though it's not the best solution, already shows that you're thinking clearly about the problem. And it also gives you a point from where to improve from. Now, you don't necessarily have to code this part, and it's usually enough just to describe how it works, kind of like I just did now. But depending on your time, you may or may not want to code this as well. The important thing is that you let the interviewer know that this is the brute force or the easy, naive solution that may not be the most efficient. At least this way you have the right answer, than running out of time and not even having an answer. Number 6 here is tell them why this approach is not the best. So in our case, we said that the code might be not efficient, or we might have not readable, or a code that is going to be really complicated and hard to read for other developers. With my demonstration, because I just want you to think about this and so I can be more clear of why this is O(n) squared, I'm going to just code, and most likely you wouldn't do this in an interview. I'm just going to code the brute force solution so you can see what I mean. I'm going to have a function, and this function is going to say contains common item, and it's going to receive 2 arrays, array 1 and array 2. Now, we are going to take the first array and do a for loop. So I'm going to say for let I equals 0. And we'll say that as long as I is less than the array1.length, so that's the length of the first array, we're going to increment I. And within this loop, we're going to have another for loop. So in the first time around, we're going to grab A from the first array, and we're going to compare it to the second array, Z, Y, and X. So we're going to have a for loop here, and we'll say that we'll have the same thing. This time, instead of I, we'll say J equals 0. And this J, as long as it's smaller than array2.length, it's going to increment every time we loop through it. And finally, within here, we're going to do a bit of a comparison. We're going to compare A to Z, then A to Y, then A to X. So if I go over here and say if array 1 index of I, so array 1 at index of I, so the first time around I is going to be 0. So that means array 1 is going to contain A. Let's actually grab this so we can see it better. At the top over here, I'm going to have 2 arrays here. And we're going to say that array at 0 first time around is going to grab A. And if that equals array 2 at whatever J is the index of array 2. So first time around, it's going to compare it to Z, so A and Z. And then as this increments, it's going to compare it to A and Y. And then this is going to increment, compare A to X. And then we go to the top loop again. I gets incremented, so it becomes 1 now. So we're going to start comparing B to Z, B to Y, B to X, and then C to Z, C to Y, C to X, and so on. If that's the case, and if this is true, we just want to return true. Otherwise, if we loop through this and this never matches, well, in that case, we can just return false here. Now, let's see if this works. I'm going to just say contains common item, and we're going to give it the 2 arrays, array 1 and array 2. If we run this, and let's make this a little bit smaller so you can see, if I run this, I get true because there's a common item of X. If I change this to now have R and I click run, I get false. Again, if we change this to A and click run, we get true because A and A match up. Looking at this, and we look at number 6 over here, that is, let's make this screen a little bit more organized so we can read this. Number 6 is tell them why this approach is not the best. Now, again, you might not have time to even code this, but we can right away see that we have 2 for loops, one nested after another. And because we've already talked about this in the big O section, we know that we have a big O when it comes to time complexity here of, well, we have an array A and another array. So that means multiply by B. Again, this is a bit of a trick because these 2 arrays can be different sizes. We can't just say O(n) squared because these 2 arrays can have, again, like I said, different sizes. So this is a bit of a trick, and it's a good thing that we wrote it out because now we see that instead of O(n) squared, this is more like OA times B. If the array sizes are the same, they'll be the same as O(n) squared, so that's pretty slow. So number 7, walk through your approach, common things, and see where you may be able to break things. Any repetition, bottlenecks like O(n) squared, or unnecessary work? Did you use all the information the interviewer gave you? And so on and so forth. Now, looking at this, I can say that we could probably do better. You might not see a solution right away, and that is because you need to practice a few of these problems to understand a common pattern. But one of the most common patterns when it comes to nested for loops is that you might be able to use something called hash tables, which we'll get to. In JavaScript, they're called objects, in order to speed things up. Is there a way to turn this OA times B time complexity into something faster? We are doing a bit of unnecessary work where we just keep looping AZ, AY, AA, and then we go BZ, BY, BA, and we're doing this comparison in the same work over and over. What if we have a better solution? I'm going to comment this out for now and scroll all the way to the bottom, and we don't need this anymore, and try a different solution. I'm going to bring the array down here just so we can see it. Now, before we start actually coding, let's think about what steps we want to take. Well, what if we had a function that takes the first array, so let's say array 1 is going to be converted to an object. And this object is going to contain something like this. It'll contain, and let's make sure we comment this out. It's going to contain A equals true, then B equals to true, C equals to true, and then finally it's going to have X equals to true. Now, if we create an object like this, we can now use this object with our array 2 to just say, array 2, can we check each item in array 2 to this object and see if a property exists? Ideally, we can do something like array 2 index and see if this equals any of the object dot properties. Okay, let's walk through this one more time. This is a common pattern that you're going to see a lot when it comes to improving time complexity. So if you don't get this right away, don't stress out. This is something that will become more and more familiar to you as we do more problems. But if I'm able to convert the first array into an object that looks like this, now instead of having to loop over both arrays, I can just loop through the second array and just simply check if the property Z exists on this object that we created. No, it doesn't. Does the property Y exist on this array? No, it doesn't. Does the property A exist on this object? Yes, it does. That means we have a common item. Now, to show you how this actually works and why this solution would be better than the first one, I need to actually start coding it. But As we go through number 8, we see that before you start coding, we want to walk through your code and write down the steps you're going to do. So let's start doing that. I'm going to say that we're going to create a new function, contains common item, and this one I'm going to add 2 because it's our second function. It's going to take in an array of 1 and array 2. And now this function, let's make this a little bit smaller so it looks nicer. There you go. This function is going to say, first, I want you to loop through first array and create object where properties equal items in the array. And then the second thing will be to loop through second array and check if item in second array exists on created object. Now, before we even start coding this, I can right away sense that we're going to have a better performance than the first array that was A times B. Because what we're going to do is have 2 loops, but these 2 loops aren't going to be nested. Remember, in the first solution, we had nested for loops. In this solution, in our second solution, we're going to have 2 separate for loops. And if you remember our big O analysis, when we have steps one after another instead of nested, the big O becomes A plus B. We have a potential solution here, have a time complexity of A plus B instead of A times B. Those are big savings. We need to start actually writing this code to see if we can solve this problem. And because this video is getting long, we're going to do this in the next video. But I want to show you right here what we've just done. And that is, although we haven't given a clear solution, we've been talking about how we solve the problem. The interviewer sees how we think, sees what steps we take, and sees that we're making smart, critical decisions to go from understanding the problem to solving the problem in a naive way, understanding why this might not be the best way, and then start to think about possible solutions. And the beauty of this approach is that no matter whether we get this part correct, maybe our assumptions are wrong and we can't do this, we're showing the interviewer that we're thinking through a problem and we're making small logical steps towards a solution. And this is a lot better than just coding right away, trying a solution, and see if you get it right or wrong. An interviewer is going to have a good understanding of your abilities and your thought process this way. And these are the type of people that they want to hire. So in the next video, let's finish out this problem, let's code it, and see if we can make this solution more efficient by converting it to OA plus B. I'll see you in the next one. Bye-bye. Welcome back. Let's get back to where we were. We want to start actually writing our code, keeping in mind that the more you prepare and understand what you need to code, the better the whiteboard will go. So never start a whiteboard interview not being sure of how things are going to work out. So, we've talked it out. We have a plan in mind. Let's start to code this. Let's do the first loop over here. That is, we want to loop through the first array. And let's remove this code just so it's a little bit cleaner. We want to loop through the first array, create an object where properties are going to match the items in the array. I'm going to create an object. Let's just call this map. And this map, we've created it, but we want to loop through our array. So I'm going to say let I equals 0. And we've done this before. I is less than array dot or array1 dot length. We're going to increment I. Now within here, we're first going to say if there is no property. So we want to check whether map.a exists, map.b exists, map.c exists, map.x exists. So if that doesn't exist, in JavaScript, we can just use this syntax. We can say if no map I. So again, if map I, which the first time around is going to be A. So if map.a is the opposite, so this exclamation mark in JavaScript means the opposite. If map A exists, it's going to return true. If it doesn't exist, it's going to say false. So this might be a little bit confusing, but we want to say if this doesn't exist, in that case, we want to do something. Now, the way if statements work in JavaScript, it needs to be true in order to execute whatever is in here. So we add the exclamation mark here to turn false into true. I know that can be a little bit confusing. You can read up on it, but essentially what we're doing is we're just checking for the property, if it exists or not. If it doesn't exist, then we're going to add it. So I'm going to say const item equals array1 I. So that is A. And this item is going to have map item equal to true. What did we just do here? Well, we said if map A doesn't exist, in that case, let's make array1 I, which is A, equal to item. So map item is going to equal to true. All we're saying is map A, in this case, equal to true. So by the end of this, we're going to have an object that is going to have property A true. And we're going to keep looping through it until we have an object called map that has all these items, map A, map B, map C, map X equals to true. All right, it looks like we're able to achieve this. And we can just console.log here just to check what we have. I'm going to say console.log map. If I run this function, let's do contains common item 2, array 1, array 2. And let's minimize this a little bit so we can see. And if I run this, I'm going to make sure I spell that right, array 2. Let's run. We see that we have A true, B true, C true, X true. Awesome. So now we have that working. Let's go through the second step. And actually, I just noticed here that this, the way it is right now, is checking I, which is 0, 1, 2, 3. But instead, we want to check A, B, C, X. So instead of I here, it should be array 1, bracket notation I. So that is A, B, C, X as the property of the map. Lots of brackets here, but I hope that makes sense. So if I run this, we should still get the same answer. Perfect. Now, let's look at the second part here. We want to loop through the second array and check if the item in the second array exists on the created object. This should be fairly simple. All we need to do, and let's remove the console.log map here. All we need to do is to loop over the second array. Let j equals 0. J should be less than array2.length. And then we're going to increment j. And all we're going to say is if map, what do we want to check? Well, we want to check if it contains the first item in the second array, that is z, as part of its properties. Remember, our map object contains these properties. So all we're going to say is we're going to check the array 2, and we're going to check the j index. So the first index, 0 of array 2, is going to be z, then y, then a. And if that's true, if it does contain those things, because remember, when we evaluate this, it's going to return true if it exists. If not, we're just going to get undefined. We're going to say return true. Otherwise, at the very end, we can just say return false. Okay, let's see if this actually works. I'm going to just click run. And I get true. Okay, so I see that A and A match. What if I change this to something that doesn't exist, like R? If I click run, I get false. What if I change this to C? I get true. If I get this to X, I get true. If I change this to W, I get false. Awesome. So we've just coded something new, a new function that, if we look at, makes things possibly better, right? Because we have two for loops, one after another, which is OA plus B, versus before, where we had nested for loops, which was OA times B. At this point, we can tell the interviewer, if the arrays are substantially large and we can get really large arrays, then this solution, when it comes to time complexity, is better. How cool is that? Now, let's go through the next steps because we're not actually done yet. Let's make this a little bit bigger. Number 11 is think about error checks and how you can break this code. Never make assumptions about the input. Assume people are trying to break your code and that Darth Vader is using your function. How will you safeguard it? So always check for false inputs that you don't want. But essentially, I now look at this code and say, how can I break this? Well, let's think this through. If I go through this code and let's say, what if I have two A's here and I run? Does this still work? Okay, what if I have A and A here? What happens? All right, I get true, that's good. But what if I have a number here instead of a string? We just assumed that the array is going to contain strings. I get false. Okay, what if I do 1 here? I get true. Okay, so that works. What if I do an empty array here? Okay, I get false. What if I do another array here? Okay, I get true. What if I do null here in JavaScript, which is a little tricky? Okay, I get false. What if I do null? I get true. Okay, that works. If we go back to what we had before, we want to now tell the interviewer how we might be able to break this code. For example, what if we don't receive a second array? What if this function is called with just one array? What happens? Uh-oh, we get an error. We want to start thinking about how errors might arise. We want to make these functions as error-free as possible. And during an interview, you usually won't have time to do all the checks that you want, but you might want to tell the interviewer possible solutions or possible ways to go around this, such as, can we assume always 2 parameters in the function? Is what happens if in the second parameter I pass 0? Okay, I still get false. What if I pass null? Oh, I get an error that says I can't read length of null. So you want to start thinking about and maybe discussing with the interviewer how you may break this function and how you may improve it, such as doing checks, such as if statements, to make sure that what the inputs you are getting are what you are expecting. Now, this is when testing comes in and testing your code comes in. During most interview, that's usually beyond the scope of the interview and you have limited time, so you can't do this, but it's good to tell the interviewer what you would do. This is one of those things that it's simple enough that you can just tell the interviewer this is what you would do versus coding it, and they will essentially give you full marks for it. Let's look at the next step. Don't use bad, confusing names like I and J. Write code that reads well. Now, when I look at this function, it's okay. Now, I say don't use variables like I and J. And although I'm using I and J exactly here, this is being used for loops. And for loops, using I here is okay because it is a bit of a standard, especially in JavaScript. And these are just simply indexes. But perhaps if these parameters had meanings, such as maybe this was the user array and this was the items array, naming these as more useful, more meaningful variables or parameters might be better. Maybe this map variable can be called tally or something more meaningful, specific for the code. Again, this is one of those things that you can talk to the interviewer about and let them know that you're thinking about these things. And that's very, very important. Again, as long as you're thinking about that and you're telling the interviewer that you're considering these things, you're getting full marks for it. Let's keep going. Test your code. Check for no params, 0, undefined, null, massive arrays, async code, so on and so forth. And we kind of covered this in the previous step, but you want to just check with the interviewer that we're making some assumptions here, but let them know that you're thinking about that. You're thinking about the fact that this function might not always be run with 2 arrays. How can we test this function, and how would you test this function to make sure that it gives the expected result, that we always return true or false? And this is where you might say that you're going to test your code and run some unit tests. Finally, even though I say finally here, there is another point, but finally, talk to the interviewer where you would improve the code. Does it work? Are there different approaches? Is it readable? What would you do, or what would you Google to improve? How can performance be improved? Well, looking at this code, I can start telling the interviewer that, okay, the downside to this solution is that, well, only numbers and strings and booleans can be used correctly because we're using an object, especially in JavaScript, and adding properties A, B, C, and X to this object. Now, object properties, especially the way we're using a JavaScript object right now, might not work if we're using non-literal values. Maybe not strings, maybe a JavaScript expression. And you might also argue that this code could be a little bit more readable. For example, although this code is better in terms of time complexity, when it comes to JavaScript, there's actually a more readable, cleaner way of doing this. Let me show you. This is something that is language specific. That means depending on how much you know about the language that you're working with, you might be able to use methods to simplify this process. So you can tell the interviewer, I would Google specific methods on, let's say, arrays to see if I can just clean up this code and make it readable. For example, I can do this exact same function, and we'll call it contains common item 3, that takes in array 1, array 2, and in one line, I can just return array1 dot sum, which is a new feature, I think ES6 with JavaScript. And I can say item using arrow functions, which come with ES6. And I can say loop through array2 dot includes and check if it includes the item. Whoops, not that item. Now, what do we just do here? Well, we're using some built-in JavaScript methods to do essentially what we've done above, which is check the first array, iterate through each item in the array, and if some of them include the items in our array 2, just return true or false. If we actually check this with our array, and I run this, and let's comment out the first one. If I hit play here, oh, I got to make sure that this is includes, not include. I get false because our array doesn't have any matches. If it does have A and A matched, I get true. Look at that. I just created a nice little function using JavaScript here. How cool is that? This is what we talk about when we say there's different solutions to a problem. We now have a way to measure different solutions to a problem. We can say that there's actually another solution using some of the built-in methods that comes with JavaScript that is, some would say, more readable, more concise. If you're working on a team that really knows their JavaScript, this is a lot easier to read than this, right? So maybe readability is more important. You might say that this is a better solution. Another thing you may have noticed is that we've talked about time complexity here. And we haven't really talked about space complexity. And this goes into a final point. If your interviewer is happy with your solution, the interviewer usually ends here. It is also common, though, that the interviewer asks you extending questions, such as how would you handle problem if the whole input is too large to fit into memory? Well, if we talk about space complexity here, we can see that in the first solution that we had, let me comment this out, we have space complexity of O1. Because we're not creating any new variables, we're just using the inputs arrays. Technically, additional space complexity for our function is O1. It's constant. But if we scroll down to this one, well, we're creating a new object here. And we're adding the first array into an object, which takes up memory. So this solution actually has space complexity of OA, which is the first array, space complexity. So if an interviewer says if there's limited memory or memory is expensive, you can just tell him or her, well, this solution, although faster in terms of time complexity, is more heavy in terms of space complexity. Now, this point here that we forgot to mention is something that, again, is really good to mention during your interview. Modularize your code from the very beginning. Break up your code into beautiful small pieces and add just comments if you need to. What does that mean? Well, we have the solution over here that we've worked on, and we've commented it out. We've modularized, saying that this first block of code is going to do something, then this block of code is going to do something else. But as code gets more and more complex, it becomes increasingly important to write in a modular way. That is, small bits and pieces that read like English. You see, long, really hard to read code costs companies a lot of money because it's not just you working on a code base. It's most likely tens, hundreds, if not thousands of developers and engineers. So companies want to hire somebody that is able to write clean code that is readable, that is easy for anyone to pick up and code along with. For example, here, what we might want to do is actually separate these out into different functions. Maybe creating a function in here that perhaps says map array to object that receives the first array item. And then maybe here another function to the outside world that says compare array to object. Now, you don't really have to do this during an interview, but it's good to mention it and talk about the idea of modularizing your code. If a function is doing too many things, that's not ideal. When we say modular, we want to build small pieces of code that do one thing and one thing really well. Ideally, a function takes an input and returns an output, and inside of that block does just one thing. If it has to do any extra actions, well, perhaps you have another function that lives on the outside world, and this function also does one thing really well. And this creates really testable, clean code that is modular. Again, something that is really good to mention and talk about in your interview. Whew. All right. I know this is a lot, and it's a lot to think about because now you start thinking, am I going to have to worry about each code that I write and analyze it this deeply? No. In your day-to-day life, you're not going to do that. But I wanted to demonstrate to you that this is the kind of thought process that really good developers have and what companies are interviewing for. If you're able to think clearly through these steps, like I have outlined for you, and you're able to solve problems this way, you see how much more impressive it is than if I just wrote down this solution without any explanation. Even if you don't get to this part and time runs out during your interview, you've demonstrated to your interviewer that you're able to think clearly. You have the fundamentals to think like an engineer. And these are great qualities that companies love to hire for and skills that are very rare. I hope you had fun with this exercise. You might have to come back to these videos later on. But for now, I'll see you in the next one. Bye-bye. Hello! I know. The last two videos were kind of long, very technical. If you weren't familiar with JavaScript, maybe they were a little bit tougher. But the point was the process of solving a problem in a coding interview. And over here, I've created a little playground for you. You remember the Google interview video that I made you watch? Well, I've implemented the solution that the interviewee created in here. We have the naive solution, which is the nested for loops, and then a better solution that uses just one for loop at the expense of creating something in JavaScript called new set. I left this here for you to play around with, and if you want, code it in your own language. But I wanted to challenge you to see if you can implement this on your own, just like the person in the Google interview did in your own language. The naive approach, and then the better approach. And try to follow these steps as you code along. Even though you already know the answer, even though you have watched the interview video, by practicing the steps and how you go from the naive to the better solution, by following these steps, you're going to improve that interviewing muscle. All right, I'll see you in the next video. Bye-bye. All right, another section done. And in this section, we talked about the technical interviews and how to solve problems specifically. One big misconception is that you're either a good problem solver or you aren't. But as with anything, it's a muscle that you can train, that you can practice. So with enough practice and knowing the tips and tricks that we covered in this section, you can solve problems a lot better. That shows the interviewer you know what you're talking about. The key in this section was this cheat sheet and the step-by-step walkthrough of a problem. We looked at how a Google interview might look like, and then we mimicked some of the techniques used there to solve our own problem. The idea was to show how you work. Think out loud and try to comment the steps as you go along to solve a problem. Communicating throughout the process as much as possible and not worrying about finishing a problem fast is the key to interviewing and solving problems in an interview. Now, we should have also gotten the idea that we don't want to memorize problems. Because if you do 100 problems and try to memorize them, well, it won't really help you long term. But you're also taking a gamble, right? You're hoping the interviewer asks you a question that you've seen before. Instead, We want to take control of our destiny and practice and be ready for anything by building the fundamentals. We talked about how by using the Big O and the lessons we learned here, we can now move on to data structures and algorithms and use them during our code interviews. We also talked about some of the skills that interviewers are looking for and demonstrated how it wasn't necessarily just coding skills. There's a lot of other aspects that interviewers are looking for. And we covered these items and how to show them during our practice interview question. Finally, we're now ready to dive into the exciting part of data structures and algorithms. We have a nice foundation, and we know that all we need is to learn these data structures and algorithms to really be interview ready. And we're also going to be using the cheat sheet that I gave you in this section throughout the rest of the course. And at the foundation of this cheat sheet is the idea of readability of code, space complexity of code, and time complexity of code. And although we didn't cover everything in the cheat sheet, we have a few items here at the end. You'll see that as we go through the data structure and algorithm questions, certain type of patterns will emerge that although questions may be different in an interview, usually the way to optimize things or tricks to make your answers better can be narrowed down to specific steps. So don't get overwhelmed. There's an easy, clear checklist and heuristics that we're going to go over later on. But by this point, I think we're ready to move on to data structures and algorithms. How do we write good code, create good programs, create value for the companies that we're interviewing for? See you in the next section. Bye-bye. What is a data structure? A data structure is a collection of values. Algorithms are the steps or processes we put into place to manipulate these collection of values. It's what allows us to write programs. A person who knows how data structures and algorithms work and how to use them can write programs, great programs. The beauty is that these are timeless. No matter what programming language you use, whether you prefer one library over the other, whether you write code in Angular or React in the front-end development world, or you're a game developer, underneath it all, it's all data structures and algorithms. If you understand these, then you can really easily adapt and tackle all sorts of technical problems. It is why companies like Facebook, Amazon, Netflix, Google ask questions specific to data structures and algorithms. Because although it may be important to know the latest and greatest JavaScript syntax, or maybe the latest and greatest library, those things change. If you know the fundamentals though, then they can throw you any problem, any situation, and you're able to make the right decision. This knowledge is extremely valuable. The longer you are in the field, the more and more you realize that you need these fundamental principles of data structures and algorithms in order to be a great developer or engineer. So let's get started with that. Over the next few sections, we have a long way to go to get familiar with data structures and algorithms so we can write great programs. Let's get started. Welcome back. What is a data structure? A data structure is a collection of values. The values can have relationships among them and they can have functions applied to them. Each one is different in what it can do and what it is best used for. Most important thing to take away is that each data structure is good and is specialized for its own thing. All right, Andre, you just said a bunch of words and I don't really understand. Well, let's show you a couple of images to simplify this. You see, you can think of data structures as any sort of compartment or container. A data structure is simply a file cabinet of different types. You have a backpack, a place where you put maybe your school books. You have drawers where you put your clothes, a fridge where you put your food, a folder for your files, and a packing box maybe for your toys. Each one of these containers are useful for its own thing. For example, I'm not going to put my food in a drawer over here because that yogurt is going to go bad here. Likewise, I'm not going to put all my papers and files in my backpack or perhaps a toy box because it's just going to get crumpled up. Each one of these containers are specific for its own thing. And that's what data structure really is. It's a way for us to organize data so that we can go into the backpack and retrieve that data really easily. We can go into the fridge and grab that popsicle or ice cream really fast. We can put things in data structures and we can take things from data structures. And that's all it really is. And there are a ton of data structures. Just like in our real life, how we have all these containers, all these places to put things in programming, we have a ton of them. If we go to Wikipedia, for example, well, if we scroll through here, we see a ton of data structures. And this is going to look overwhelming, but don't worry. Most of these, well, I've never encountered myself, and they're very, very specific. You probably only have about 5 or 6 data structures that are really, really important that we're going to go over. And you may have even heard of Bitcoin and how it uses blockchain technology, this magical word. Well, blockchain at the end of the day is simply a data structure, a way to hold information. So in our programming world, data structures, we can store things like numbers, strings, Boolean types, just like we saw when we coded in JavaScript with arrays and objects. Arrays and objects in JavaScript are each a form of a data structure that allows us to store information. You see, as humans, this is what we do on Earth, right? We take the chaos and the disorder and make order out of it. At least we try to. We organize our farms to produce food. We package the food and we deliver them to the grocery stores and organize them in the grocery store so that humans can grab those and can then purchase these groceries and give money to put in a compartment and a bank. That's what programs are. We're modeling real life scenarios. And the more advanced a developer you become, the more time you'll start thinking and spending time talking about data structures. This is why interviewers love to talk about data structures. Now, as I always like to mention, there are always trade-offs. Every programming question has a trade-off. Remember our 3 pillars of readability, memory, and speed? When we talked about what code is best? Well, we have the same thing with data structures. One is better than the other in some aspects and the other better than the other. That's why they exist, each one for its own specific case. And there are 2 parts to understanding data structures. One is how to actually build one. How can we build with code some of these data structures? And 2 is how to use them, how to use these data structures. We're going to do both of these in this course. But the second point is the most important, right? Because data structures are usually just tools. And most of the time, they're already pre-built for us. The most important part is how to use them, when to use one over the other. And we kind of saw a little bit of that in the previous section when we talked about how to solve problems, where we used an object versus an array to make our code more efficient. The goal in this course is to understand data structures so that you can pick the right data structure for your problem. Based on different scenarios, data needs to be stored in a specific format. We have a handful of data structures that cover our need to store data in different formats. So let's get a little bit deeper into this topic. In order to truly understand the value of data structures, we have to go deep down into the way a computer works at the fundamental level. In order for a computer to run code, it needs to keep track of things like variables, like numbers, strings, array. These variables are stored in what we call random access memory, or RAM for short. That's how programs run. We remember this from space complexity video, right? On top of that, we also have storage, where we store things like our video files, music files, documents. And the storage can be a disk drive, a flash drive, or a solid state drive. Data on storage is permanent, or what we call persistent. So when you turn off your laptop or computer, it's still going to be there when you turn it back on. In RAM, you lose the memory when the computer turns off. So why wouldn't we just always use storage so we don't lose any data? Well, the problem is that persistent storage is slow. Because you see, a computer is run by its CPU. You can think of the CPU as the little worker that does all the calculations that we need. It does the actual work inside our computer. And this CPU needs access to the RAM and the storage. But it can access the RAM and the information in the RAM a lot faster. But let me give you an example as if we're using Google. When we run Google Chrome, for example, a browser, that Google Chrome browser has a piece of code. Now here I've simplified it, and we just have a variable a equals 1. We're just assigning this variable 1. But we can imagine how we have hundreds, thousands of lines of code of Google Chrome. Now, in order for our computer to run Google Chrome, we run the CPU for it to do so. Now, when a variable is declared in, let's say, a script to run Google Chrome, it's going to hold that in memory, in our random access memory. But once we turn off or close Google Chrome, we want to be able to reopen it, right? Well, that's what we do when we save an application on our computer. We save it to storage so that next time we open up Google Chrome, the CPU is going to grab the program from the storage so that it can use it again. And for Google Chrome to run fast and run smaller scripts, it's going to keep that information in random access memory. We can see this on our computers as well. If I go to About this Mac, my computer, we can see here that we have the processor, which is my CPU. We have my memory, which is my RAM. And if I go to storage, this is my flash storage, my persistent storage on my computer. So you can think of RAM in the computer as a massive storage area, kind of like a data structure, right? Well, this massive storage area has shelves that are numbered. We call these addresses. And it's a really, really big shelf that holds a lot of information. And it allows us to run programs on our computer. Now, each of these shelves holds what we call 8 bits, or numbers. If you see here, 1, 2, 3, 4, 5, 6, 7, 8. Each one of these numbers is a bit. And a bit is a tiny electrical switch that can be turned on or off. But instead of calling it on or off, we call it 1 or 0. And 8 bits is called a byte. Each shelf has 1 byte of storage. And the CPU is connected to something called a memory controller. And a memory controller does the actual reading of this memory as well as writing this memory. Because sometimes this shelf might be blank and doesn't have anything. Now, this direct connection to the CPU is important because the CPU asks the RAM, hey, what's in shelf number 0? And the memory controller actually has connections individually to all of these shelves. Again, that's really important because it means that we can access the 0 shelf and immediately access the 7th shelf or 10,781 shelf without having to climb down or step down. That's what the name random access memory means. We can access memory really fast because we have these connections any shelf we want. We just need to know which shelf we're looking for. We can access the bits at any random address in memory right away. Even though this memory controller can jump between far apart memory addresses really fast, programs tend to access memory that is nearby. The closer the information is to the CPU and the less it has to travel, the faster a program can run. So computers are actually tuned to get extra speed boosts when reading memory addresses that are close to each other. For a computer to access 0 and 1 is a lot faster than a computer for it to access 0 and 1,000, because these are a lot closer together. And to further optimize this, our computers also have what we call a CPU cache, where the CPU has a tiny, tiny memory where it stores a copy of stuff that is really, really recent. And this is called a cache. A common one that you might hear is something called LRU cache. So again, if we use Google Chrome as an example, we turn on Google Chrome with, let's say we have the application downloaded on our storage, the CPU loads it up, and because we've visited hackernews.com, it's going to load up the information for that Hacker News and put it into memory, or maybe even cache, if it can hold it. So, why is this important for data structures? Well, data structures are, remember, ways for us to store information. For example, if we want to store variable a equals 1, well, in our modern computers, usually we represent integers, that is the number 1, in 32 bits. That is this block size of RAM. And by the way, this is now can be 64 bits with more and more recent upgrades. But this way, we can store the number 1 within this blocks of 32 bits. Why 32 bits? Because 8 bits, which is 1 byte, times 1, 2, 3, 4. So 8 times 4 is 32 bits. We can store 32 bits of information. And this bit of 1, you can see here, 0, 0, 0, 0, 0, 0, 0, 0, 0, and 1 is stored now in memory 0, 1, 2, 3, or the address 0, 1, 2, 3. If we have another variable, b equals to 7, we would store it in the next block over here in our RAM. In doing this, you can now think about how systems that are 8-bit can hold 255 bits of information. Things that are 16-bit, well, they can hold a lot more information. And now we have systems that are 32 bits. You can see here that we can hold a ton of information. And then if we had 64 bits, that is, instead of having 4 little shelves over here, we have 8 shelves. Shelves times 8 bits. Well, that's a lot of information that we can store. And the bigger this is, the more diverse that information is. If we had an 8-bit system, well, the number 256, we can't really store that. That's really hard to do. And I can demonstrate this to you with JavaScript. You see, there's something called integer overflow. Now, JavaScript technically doesn't have integers. It only has what we call a 64-bit floats. But the idea is that a computer can only store a certain number of information. So using this syntax in JavaScript, we have math.pow, which is a function that returns the base to the exponent power. That is, the first parameter is the base to the power of the second parameter. So we can create really large numbers like math.pow, so 5 to the power of 100. If I run this, we see the number over here. If I increase this to, let's say, 6, again, another large number. Now, what if I keep going and change this to 6 to the power of 1,000? We get infinity. What is that? Well, as the number becomes too large to store in our RAM, then we need to represent this number that we cannot store into something that is tangible. In JavaScript's case, it is infinity. We can only store this much information, and no matter how big I make this, any number above a certain threshold is going to just say infinity. How cool is that? Now let's go back to the slides. I showed you all of this because other data types other than numbers work the same way. Each data type has a number of bits associated with it, and that needs to get stored in the system. And the system allocates that storage, and then the CPU reads from that storage. Now, I'll leave a link for you after this video so that you can get more information if you want. We don't want to get too deep in this. But a data structure is this. A data structure is an arrangement of data. You can define the way you interact with this data and how it is arranged in RAM. So some data structures in RAM are organized right next to each other. Some are organized apart from each other. And they have different pros and cons on access and write. Our goal is to minimize the operation that we need to do for the CPU to get the information, for the CPU to write information. And that is why data structures are so powerful. We're thinking about the low level. And I don't know about you, but this to me, when I learned about this, was really, really exciting. Because we have a way now to think how data structures actually affect the process of our computers, and how we can use what we know about computers now to write great code. I'll see you in the next video. Bye-bye. Welcome back. There are quite a few data structures that you may be asked in an interview, and we saw how many of them there are on that Wikipedia page. But luckily for you, the list isn't actually that intimidating. All you need to learn are these ones over here. These are used, I would say, 90% of the time. And this is what we're going to talk about in our course. Now, there may be specific ones within these groups, and each one of them has trade-offs. But as long as you learn these and you learn when and why you should use them, then you're going to be miles ahead of most people. It's going to be a lot of fun. Now, before we get going, I want to note one last thing. You see, each language has their own data types or built-in data types. JavaScript, for example, has numbers, strings, has booleans, which are true, false, and then some strange ones like undefined. And each language has data structures to organize these data types. So for example, in JavaScript, we have arrays and objects that we use. And they are data types. It allows us to structure and organize information such as our primitive data types, or even hold more complex ones like having an array that contains multiple objects. And we're going to talk about this in more detail, but I want to show you that we do have different languages that have different access to some data structures. You can see over here some of the other languages that we can use in this course and whether they have them available. We see that Java has arrays, has linked lists, stacks. We have priority queues and many other types. Now, does that mean that if we're using JavaScript, we can only use arrays and objects? Well, no, not really. Although these languages come with data structures built in, we can also build our own. And most languages have enough data structures and data types for us to build and create our own data structures. So if JavaScript doesn't have stacks, well, we can build one. Now, to finish this section and finally dive into our first data structure, I wanted to just remind you that we have a little map over here of what we need to know for the coding interview. Now, in this map, I have a little present emoji next to each one of the data structures that we're going to talk about. As you can see, there aren't that many of them, and many of them are quite related or are children of the other. But use this as a reference for you to just draw a map of how things are connected and what the data structures are that we're going to talk about. But let's get our hands dirty with our first data structure. I'll see you in the next one. Bye-bye. What are the various operations that can be performed on different data structures? Because as we learned in our previous lectures, data structures are simply ways to organize our data on our computers. And the data structures we'll see throughout this course are simply variations of how we store this data on our computers, this information. And each data structure has their trade-offs. Some are good at certain operations, others are good at other operations. One type of action that we're going to perform with data structures, well, is insertion. Add a new data item in a given collection of items, such as us adding the Apple item in memory here. Another one? Well, deletion. We want to sometimes delete data, such as remove Mango from our list. Another type of action might be traversal. And we're going to see this a lot. Traversal simply means access each data item exactly once so that it can be processed. Another useful one is searching. We want to find out the location of the data item if it exists in a given collection. And then we also have things like sorting. That is, having data that is sorted, kind of like it is on the left-hand side over here, versus the right-hand side where there's not much sorting going on, at least from what we can see. And obviously, the main one, and probably the most important, is access. How do we access this data that we have on our computer? Now, each data structure that we're going to go through in this course will have different pros and cons for each one of these. And if we take a look at our Big O cheat sheet, well, we're very familiar with this diagram over here, or this graph. And if we scroll down, we have all these data structures that it lists. And don't get too overwhelmed. We're going to go over most of these data structures, and you see that half of them are mainly trees and variation of trees. And within here, we see that each one of them has access, search, insertion, deletion, average, and worst case. And because we understand Big O, we can see that, all right, we're seeing which one's good for what and what is bad for what. And as we go through our data structures, we're going to go over these pros and cons so that you build the foundation to be able to decide which data structure should I use on your next problem. We're going to get started with our very first data structure in the next lesson. I'll see you in that one. Bye-bye. Woohoo! It's finally time to learn our very first data structure, and one that most likely you're very familiar with. Arrays. Arrays, which are sometimes called lists, organizes items sequentially. That means one after another in memory, kind of like we have here. We have some sort of data at index 0, let's say juice, and then right after at index 1, we have something else, maybe apple. Maybe this is a grocery list. In our computer's memory, it'll be one after another. Because remember, our RAM is a lot bigger than just 7 slots. And arrays are probably the simplest and most widely used data structures. And luckily for us, we're starting with this because arrays have the least amount of rules. And because they're stored in contiguous memory, that is, in order, they also have the smallest footprint of any data structure. So if all you need is to store some data and iterate over it, that is, go one by one, step by step, arrays are the best choice. Especially if you know the indices, that is, here on the left, of the items you're storing. And just as a quick glance, and we'll go over this in more detail in later videos, but lookup or access with arrays are constant time of 1. It's super fast. Other actions or methods that we're going to go over, such as push, are also fast, but then inserts and deletes are O of n, or linear time. But in order to demonstrate arrays, let's actually use code to show you an example. We have our little playground over here. And again, you can use whichever language you prefer. I'm just going to demonstrate this in JavaScript. We can create a simple array. Let's call it strings. And this array, again, using the square bracket notation, will have A, then B, then C, and D. And we've just created an array in JavaScript. Now, looking at this, and based on what we've learned so far, we can make a couple of assumptions. For example, to store the letter A, letter B, letter C, letter D, that's 1, 2, 3, 4 items. If we were on a 32-bit system, that is, we have 1, 2, 3, 4 shelves to store the letter A in zeros and ones. Well, if that's the case, we just multiply 4 times 4. So 4 items, and each item taking up 4 shelves in our memory. That means we're using up 20 or 16 bytes of storage. If we remember in our little example here that with a 32-bit system, we have 1, 2, 3, 4 shelves to store this number. Again, this is a bit of a simplified version of looking at it, but I hope you see what we're doing here. We're simply storing A, B, C, D in sequential order in our RAM, our random access memory. So the computer now knows where to find these items. Therefore, when I do strings 2, I'm telling the computer, hey, go to the array called strings. You should know where that is because underneath the hood, you stored it for me. And grab the third item. Remember, the indexes are 0, 1, 2. So grab the third item from where the array is stored on your memory. And if I run this, I'll get C. The computer is going to grab that information for me because here it stored it for me and here it's grabbing it for me. All right, so let's do a few more operations with arrays and see what the pros and cons are. Well, in JavaScript, we have a few methods that we can use with arrays. One is push, which simply allows us to add something at the end of the array. So strings dot push E. And if we just remove this, and let's have a console.log of strings. If I run this, I get A, B, C, D, E. This string push operation, because it just adds it at the end of the array, is an O1 operation. All we're doing is adding whatever item we want at the end. We're not looping through anything. So hopefully that makes sense why that would be O1. That's very convenient. What's another method that we get? We can also use pop. And pop is the opposite of push. Pop will simply mean to remove the last item from the strings, from the array. If I click run here, you see that the E was moved. If I do strings.pop again and hit run, we see that this time around we've added E, then we removed E, and then finally D to be left with A, B, and C. What do you think the time complexity of this operation is? Once again, it's O of 1 because we're not looping through anything. We're just removing the last item. And remember, our computer knows where last item is stored. We're simply saying, go to index of, let's say, 7, the very last item, and remove the bread. But let's do something interesting here now. What if we want to add an item at the beginning of the array? Maybe in here we want to add the letter X. Well, we have something called onShift in JavaScript. And depending on your language, you'll have perhaps something different. But the idea here is we simply do strings.onShift. And by the way, you see here how REPL.it actually gives you the parameters that you can enter. In this case, it just says what items, which is a string, should I enter. In our case, I'll say I want to unshift X, which is saying just add X at the beginning of the array. If I click run here, we see that X has been added at the beginning of our array. What do you think the time complexity of this operation is? And by the way, as we go through data structures and because we know Big O notation, isn't it pretty cool that we're able to think about code beyond just, oh, I'm just doing this. We can think deeply about what's happening underneath the hood. Why might this operation be longer than this operation? I find that fascinating. And when I first understood this point, it really made me a better engineer. And I hope you're starting to get this aha moment for you as well, especially if this is your first time with data structures. Now, on Shift, what are we doing here? Well, remember, strings are essentially stored. If I move this to a new line, the computer knows that this is at 0, this is at index of 1, this is at index of 2, and this is at index of 3. When I add X with the onShift, I'm all of a sudden adding X into our array, but we now have to shift these numbers because the indexes are still like this. But this time around, we have to say, okay, 0 is now at X, A is now 1, B is now 2, and C is at index 3, and D is at index 4. And just by me doing this, you might have seen something. We just iterated, looped through everything, and reassigned the indexes. And I did 1, 2, 3, 4, 5 moves, or 5 operations to realign the indexes. And this should give you a hint. That is, this operation is O of n. Depending on the size of the array, that's how long it's going to take to do that operation. We're looping. So right away, we know that, with arrays, maybe it's not the best data structure for adding items at the beginning of the array. What if we wanted to add something in the middle of the array? So we can use the method splice here. Let me scroll down a bit. And with splice, I can say strings.splice. And again, I get a hint of what I can do. The first is the start number. So I want to start at index of 2. And remember, we have this array here, X, A, B, C. So we're starting at B. And the second parameter is the delete count. What do we want to delete? Or how many things from this index do we want to delete? In our case, we don't want to delete anything. We just want to add. So I'll say 0. and then the items that we want to add. So let's just add a string that says alien. Oh, and let's remove this X from our original array. That's better. Let's hit run. And there we go. We have X because we've unshifted A, then alien, B, C. So splice told us go to index of 2, 0, 1, 2, where B was initially, and add alien instead of B and just shift things over. So what we've done here is, if we go back to our example, we have the X in our array, and we shifted these indexes of X and A are still the same, but we shifted B over and said, in here, I want you to add alien. And we now had to go over everything and say 2 for alien, we want 3 for B, 4 for C, and 5 for D. So what's our big O here? We don't need this comma. Well, our big O in this case, we did half of the operations because we changed half the array. We looped through half the array. So it would be O of n divided by 2. But remember, our rules when it comes to big O, we remove constants and simplify to just O of n. Worst case, it's going to be O of n operation. All right. I'm going to leave this for you so you can play around and try different methods on arrays. But I hope you understand how they work and how there's some good things that we can do, such as accessing the array. That is O of 1 because it's, well, extremely fast. We know exactly where it is in memory. We can push and pop. But when it comes to unshifting or splicing or even deleting, because with splice we can even do deletes, that's going to be O of n. And if we go back to our chart, we should now have a better understanding of why arrays lookups are extremely fast. We know where they are. We know why push, adding at the end of the array, is extremely fast. But why inserting and deleting might not be the best or the fastest when it comes to arrays. But here's the thing. There's actually 2 types of arrays. And in the next video, we're going to talk about these 2 types. I'll see you in that one. Bye-bye. Welcome back. As I mentioned in the previous video, there are actually 2 types of arrays. One is called static, and the other, dynamic arrays. Now, what is the difference between the 2? Well, the one limitation of static arrays is that they're fixed in size, meaning you need to specify the number of elements your array will hold ahead of time. So in this case, if this was a static array, I would say create an array of 7 items, knowing beforehand that in my grocery list, I'm only going to have max 7 items. Because arrays are allocated in adjacent blocks of memory when they're created, there's no guarantee that after we've allocated 7 shelves of memory that you can keep adding things on, especially in order. We solve this problem with static arrays that require us to say ahead of time, hey, I only want 7 shelves of memory, with dynamic arrays. And dynamic arrays allow us to copy and rebuild an array at a new location, which with more memory if we wanted more memory. So for example, with our static array, if we realize that we forgot another item on our list and we need 8 items, what happens is we copy this entire array, we allocate 14 blocks of memory, and paste this list plus the 8th item into that new location. Let me show you how this works with code. You see, in languages like C++, let me scroll down over here. In C++, which has static arrays, to create an array, you do something like this. You would say int a 20. And this says, I want an array that has space of 20 items. Or you can do something like int b5, and then fill up the array of 5 items with 1, 2, 3, 4, 5 integers. That's what int stands for, numbers. And because of this, and because this is a static array, in order for us to add a 6th item on here, well, we would need to copy this entire array and move it over to a completely different area of memory in order to create the space for it. Now, luckily for us, when I showed you with JavaScript how to do this, well, we never had to worry about it, did we? In our JavaScript example, we never really allocated memory. And that's because in JavaScript and other languages like Python, where you have lists and array list in Java, they work like dynamic arrays. They automatically allocate memory according to the increase in size of the array. So right off the bat, you're thinking, dynamic arrays are way better, easier. I don't have to think about memory because of automatic resizing. And that gets into a discussion of managing memory, which low-level languages like C++ allow, while higher-level languages like JavaScript allow us to not think about memory and let the machine take care of it for you. There's times where maybe you do want to manage your memory and times where you don't need to, based on your needs. Obviously, having more control over memory allows you to really tweak things and make things faster. And that's why languages like C++ can be much faster than higher level languages like JavaScript. But we don't need to get into that. What we want to get out of this lesson is that dynamic array expands as you add more elements. So you don't need to determine the size ahead of time. But you may have noticed something with dynamic arrays. You see over here how I have append at O of 1. That is the same as the push command that we did in the previous lesson. But I have a star here that says it can be O of n. Why is that? Well, if we remember our array, and let's remove the extra items here that we don't need. So just say A, B, C, D. If underneath the hood, JavaScript and our machine only created 4 blocks of memory for this array, and we add another letter, underneath the hood, because this is a dynamic array, it's going to loop over these items, copy them, and move it to a different location with now 8 blocks of space, so that we can keep adding onto here. And you see here, because we did this looping, the operation becomes O of n. So that's something to keep in mind. Although it's a minor detail, it's good to know how things work underneath the hood. And most of the time, with the languages that you're working and during interviews, you will be talking about dynamic arrays, and you won't have to worry about allocating memory and thinking about the possibility that you might have to copy the array. That's really low level. But I wanted to show you how they work so that you have those fundamentals going forward and understand that when it comes to arrays, just because you're adding at the end using the push command, you can't assume that it's O of 1 most of the times or constant time. But every once in a while, you might encounter a situation where it's O of n, linear time. I'll see you in the next video. Bye-bye. Welcome back. We're going to talk about some advanced objects concepts. Now, as I said, with both arrays and functions, these are advanced concepts. You're probably not going to just get it 100% the first time around. But use these videos as a reference to come back as you progress through your career. Now, in this video, I'm going to talk about 3 things that are important with objects. We're going to talk about reference type. We're going to talk about context. And finally, we're going to talk about instantiation. So let's get started with the first one, reference type. What do I mean when I say reference type? Well, I want you to see if you can guess what's going to happen when I do array equals array. What do you think the answer is going to be? Let's see. Interesting. Okay, what if I do array1 equals array1? Interesting. Okay, one more question. What about something like this? Object1 equals value of 10. And we'll say object2 equals object1. And we'll finally say variable object3 equals value 10. So looking at these, and I'm actually going to copy it on here so you can see it as well. Looking at this, what happens if I do object1 equals object2? What do you think will happen? True. Okay, that makes sense. I mean, object2 is object1. But what if I do object1 equals object3? Here I get false. But why is that? We have value 10, value 10. They're both the same thing, right? Let's check something else. What if I do object1.value equals 15? Okay, and now I do object2.value. It equals 15, but if I do object3.value, I get 10. Well, that was confusing, right? Let's look at what's actually going on. And this is the first topic we're talking about, which is reference type. Let's look at a diagram. Objects are what's called the reference types in JavaScript. Up until this point, all the other JavaScript types that we've learned, including numbers, null, we have undefined, booleans, strings, even symbols, they're all defined by the programming language. So JavaScript, the person who wrote JavaScript, and ECMAScript, the standard, says these are primitive types. We tell you what they are. Now, a reference type, which is a non-primitive type, are not defined by the programming languages. What that means is that they're created by the programmer. So let's look over here as an example. When I say variable number1 equals 1, JavaScript knows what 1 is. It's a number, and it's a primitive type. It's always the same thing. It's immutable. Every time it uses a 1, that's the same one that JavaScript knows about. When I do variable number2, yep, it's using the same number1 that JavaScript knows about. However, when we created object1 equals value 10, and object2 equals object1, and object3 equals value 10, well, those were created by the programmer. They're reference types. So what we said was, I want object1, create a new object. We'll say this box over here, this filing cabinet, and in it, put value 10 into this box. Object2 says, I want you to just reference, and that's where the word comes from, reference object1, saying, hey, I want whatever's inside this box. when object 3 gets created, it's a new object because we have the new brackets, and it's saying put value 10 in this box. Essentially what we're doing is saying when we create variable object 1, we're storing just a reference, an address to where we're storing the value 10, which is box 1. So we're saying object 1, I'm just letting you know that this is the address of all the contents that you want. And that's in box 1. Object 2 is saying, I want whatever is in object 1, and we look in object 1, and object 1 just has the information of box 1. So it references that. And object 3 creates a new object, so it's saying, I'm going to put my contents in box 3, and I'm just going to have the address of the box saying box 3. That's right over here. So going back to our example, this makes sense. When we changed object 1 value to 15, we changed the contents of box 1. So when we do object 2 dot value, which is referencing the same box as object 1, that's 15. But object 3 dot value doesn't change because that's interested in a completely different box. It's box 3. And going back to the first example, arrays, well, as I mentioned in previous videos, arrays are just objects at the end of the day. So when you create an array, it's the same thing, creating a box, a data structure, and this is creating a second data structure. All right, so that is reference type. A very important concept, but I think you get it, right? Let's get to the next one. This gets a little trickier. This one's called context. And context gets confused a lot with scope. If you remember, we said that scope is created when it sees curly brackets, right? We said that if we create a function, as soon as we create that function, there's a new scope that's created. So we can have let A equals A, and that lives within this universe. It doesn't know anything about the root scope, which is over here. So if I do console.log A, well, it's not going to work. Oh, and we need to actually assign something, and we need to name it. So let's just say B. So if I do this, well, console.log A will just return reference error because it doesn't exist. So that's scope. Now, how is context different? Context tells you where we are within the object. Let me explain. If we say console.log this, well, you see, I get some highlighting. And this is the first time we're seeing this. And it's a special word in JavaScript, probably the most confusing word that a lot of people have trouble in. Even people that have been in the industry for years still have a difficult time with this. But let's see what it is. This is, as you can see, the window object. So just to double check, if I do console.log this equals window, I get true. And I can access this dot alert hello. So what this means is, what is the object environment that we're in right now? The best way to think about it is, what is to the left of the dot? So right now I'm able to do alert because I'm inside the window object. So doing window or doing this is the same thing. Now, why is that important? Well, when we get to instantiation, I'll show you why it is. But it's a very important concept that you'll see again and again. But remember, this just refers to what object it's inside of. Two more examples to demonstrate this. One, is if I do function A, within function A, we'll say console.log this. So if I call A, what do you think happens? Let's see. Still the window object. This still refers to the function. And if you remember, that's because I said it has to be what object we're inside of right now. Technically, function A, I can go window.a and run the function. So to the left of the dot, well, that's the window. In order to create a new value for this, you have to do something like this. Object A, function A. Now if I do function, and within here I do console.log this, well, in that case, if I copy this and run object for.a, well, now this is the object, which is object 4. So why is that important to us? Well, first of all, you'll see it in other code bases, so it's good to know. But it's really important when we do instantiation. Instantiation is when you make a copy of an object and reuse the code. Imagine you're building a big multiplayer game online. And this game's going to have many, many players. You can have wizards, you can have trolls, warlocks, elves. Now, if you had to create an object for every single player, that's a lot of repeated code, that's a lot of hassle, and well, that's a lot of your time, and it's not very efficient. To solve that, you can do something called instantiation. You're making instances or multiple copies of an object. So let me show you how we do instantiation in JavaScript. Again, this is going to look a little bit weird at first, just like for loops did, just like functions did at the beginning, but it's just the syntax and you'll get used to it. So let's say we have a player class. Now you see the new syntax already, and I capitalize a class. Now think of a class as something that I want to make a copy of. If I ever want to make a copy of an object, it's a good idea to do something like this so that, well, you'll see how easy it is to copy this now. So we do class player, and within here, we'll say constructor. And I know this looks weird, but again, it's just syntax. Let's give it, this player can have a name and a type. And within the constructor, this.name equals name, and this.type equals type. Oh boy, what just happened here? Constructor, when you create a class, a player class, says every time I'm making a copy of a player, the first thing that gets run is the constructor function, and this constructor function is going to create these properties on the player object. So a name and a type. And now I can create anything that I want for the player. Let's say we want to create a method such as introduce that console.logs with backticks. Hi, I am. And again, we remember the syntax template strings. This.name, I'm a this.type. Awesome. So now I'm saying this player class, any player that I create will always be able to introduce themselves. And they'll also have this name and this.type. And the reason we use this here is that when we create a player, we can access the name and type property. I'll show you later on how that works, but this is just a syntax you're going to get used to. In order to access the player and make copies of it, you'll have to run a constructor, which is all the properties and methods that you want the player to have. You can also create methods that players can have. And anytime you want to access a property within the constructor, we'll use this .name. If I want to use introduce, I'll have to do this .introduce. Okay, so we have a player, but when we're building our multiplayer game, we want to now copy this but add on to it. Let's say we want to create a wizard player, a player that's a wizard. In that case, we would do class wizard, again, capital letter, extends, and again, it's just a JavaScript keyword, player. So what is this saying? I'm saying I want wizard to extend whatever player has. So I want to add on top of whatever player has. Again, because it's a class, we'll have to do a constructor. And this wizard is going to accept name and type. And within here, this is the tricky part. Anytime we extend something, we need to also call the constructor function of the player. We have to do something called super with the properties that we want to pass to the constructor. In this case, name and type. I know this is confusing. It's just something you have to do. Whenever you extend a class, you want to use super so that you essentially have access to these. Okay, so let's say that with the wizard, we also want to have a play function. And the play function will just console.log I'm a this type. And now that we have our wizard, what's the power? What's the reason that we just did this? Now we can do this. Instead of constantly creating players and then saying that they are wizards and they can play, now I can say wizard1 equals new wizard, and we'll call the first wizard, again, we get name and type. So we'll say Shelly, and she'll be a healer. And if I want to create a new wizard, I'll just say wizard2 equals new wizard, Sean, and he is dark magic. Whew, that was a lot of new syntax. So let's go through it and make sure we understand everything. As we've learned, let's use console log to really understand what we're doing. I'm going to add a console log right at the top over here. And we'll say this. What is this? I'm going to save. And actually, I'm going to copy this into the console. Let's copy it and see what the console log gives us. We see that we get wizard. All right, let's go through everything here. I say we have a class player, then a class wizard that extends player, and then we have two variables that we created, wizard1 and wizard2. Now, the program is going to see the new keyword, and anytime it sees the new keyword, it says, oh, we're creating a new wizard. And this wizard is going to have two parameters, Shelly and healer. So it's going to go to the wizard class. Again, because it has this new word, it goes to the wizard class and it says, hey, wizard, I want you to extend player. So it's going to go to the constructor and it's going to see this super. And what this does is it takes us up to the constructor of the player and it runs this. And now it attaches this as the wizard. And then it introduces the new function and then adds the play function. Now, if I go to wizard1 and I say play, I get I'm a healer because Shelly's a healer. but I also have access to wizard1 dot introduce. Hi, I am Shelly. I'm a healer. And we also have access to wizard2. Oh, I have to run this again. Let's run this again. And I don't think I copied the second wizard last time. So now I have wizard2 introduce. Hi, I'm Sean. I'm a dark magic. That sentence doesn't make sense, Sean, but that's okay for now. Let's just try something. If I do console log here, and we'll just say wizard, and here we'll say player just so we can distinguish between them. And I'm only going to copy the first wizard so that we don't get two of these running. Again, because we're creating two wizards, we're going to have this run twice. But just for our sanity, we'll run Shelly. So I'm going to refresh and add here. Oh, I forgot to add a comma. And let's refresh. And I get an error. Reference error, must call superconstructor and derived class before accessing this. What that's saying is that in order for me to access this and get this.type, I have to call super, which runs a construction function in player. So that's what super is doing. It sounds kind of weird, but it's just something that you need. I'm just going to put this at the bottom after we call super. And now it should work. Let's see. I get the first player, wizard. So we call super. As soon as we say new wizard, Shelly healer, I go to the wizard extends player. I run the constructor function, which says super. Hey, run the constructor function in the player. And I run that. And that's why we log console log player first. And then we go to console.log wizard and then run the rest of the class. Very cool. Now, just to show you something, this is actually new syntax that you'll see in React, and it was part of ES6. But back in the day, this is how we used to do it. The exact same code I have up there is right here. It's called classical inheritance, and it doesn't look too bad, but you see that there's prototype, which it's another thing that you'll see in JavaScript, and to be honest with you, you shouldn't really use it. It doesn't look very nice. And you see that we have to attach play to both wizard1 and wizard2, and it just doesn't look as nice as this. And once you get used to everything, it's not too bad. All we're saying is, as soon as we say class, we say, hey, we're probably going to make a copy of this object. So we want to make copies of player, we want to make copies of wizard, and that's called instantiation. When I do the new keyword, I say, make an instance of wizard. And wizard uses some functionality from the player and adds its own little play function as well. Holy moly, that was a lot. Like I said, this is something that you'll have to come back to, and you won't get it right away. It's really hard to fully understand the topic without actually having to use it in real life. Just keep this in mind. Every time you hear somebody talk about reference type or context or even scope or instantiating something, well, these are the things that they're talking about. Objects are really complicated. They're really hard, but with that, it gives us a lot of power. So with that, good luck with the exercises. I'll see you in the next one. Bye-bye. Now that we know how to use arrays, where they're fast, where they're slow, we're going to get into a part that is not crucial for interviews, but it's good to understand how they work and how to build an array. Most likely in an interview, you won't get asked, hey, build an array from the beginning. But I do want to build those foundations for you so that we understand arrays from a fundamental level. So let's build an array ourselves. Now, in this video, we're going to be using the class syntax in JavaScript. So we're going to create an array class. Even though with JavaScript and many other languages, we can just do this and we've created an array. Let's see if we can build one of our own. Because as you'll find out as we go through this course, data structures are simply things that we can build from scratch. We can create whatever data structure we want. We can create our own data structure. The most common data structures are well known and are already implemented in most languages because they're so useful. But you are able to build any data structure you want from scratch. And as you'll find out, most data structures are built on top of other data structures. Now, to get started, we're going to create an array in JavaScript. But just a heads up, JavaScript is a bit of an interesting case. Arrays in JavaScript are just objects with integer-based keys that act like indexes. And that's what we're going to build. Different languages will have this implementation differently, but what we're going to learn here is still going to be applicable to how arrays work in other languages. So we're going to start off with creating a class. Let's start off with creating a class, and we'll call this myArray. And within the myArray, we'll have a constructor, which is the initial function that will be run when we create this myArray. And this constructor is going to have two data points. One is the length property, because with an array, we're able to determine the length of the array. And the initial length will be 0. That is how many items the array has. And then we'll obviously have the data within the array. And this is going to be an object. Now, what's the most common action that we have in an array? Well, it's the access, to access the data. So let's create a get method. And this get method is going to take an index to actually grab the data from memory. So I'm going to just say return this dot data. And if this keyword is confusing to you, make sure you watch the previous video. This dot data is just referring to this data that we've created in the constructor. And we're just going to return the data at the index that we're requiring. Let's see how this would work in action. To create a new myArray, all we need to do is say const new array. And we use the new keyword in JavaScript to instantiate this or create a copy of this class, like this. So now if I do console.log new array and I click run, I get my array that has property length of 0 and data that is empty. If I do new array dot get 0, index of 0, I get undefined. Well, because there's nothing in this object. We have no items. And JavaScript automatically has the type undefined when, well, there's nothing. Let's add our next method. That is the push method to add something at the end of the array. So I'm going to create a push method, and this method will take in an item that we will give it. And within here, we'll simply add this to the data of our object. It's going to add it to the length of our item. So because we have 0 items and the length is 0, this is going to add the data at this.data 0 index. And the 0 index will simply now contain the item. And because we want to keep adding items if we wanted to, we will say this dot length plus plus, because now our array has a length of 1 instead of 0. So that next time we run the push method, this dot length will be 1 and the new item will be added at index of 1. And let's just return this dot length for now, because the typical push method in JavaScript will usually return the length of the array. Let's run this and see what happens. I'm going to say that down here we'll have new array dot push, and we're going to push high. If I run this, I see I have my array length 1. Data is going to have a property 0 of high. Nice. What if we add another thing? Let's do new array dot push, and we'll say u. If I run this, I have length of 2 now with index of 0 at high, or index of 0 has high, and the index of 1 has u. Very cool. What else can we do? Well, let's add the pop command to remove the last item of the array. Once again, we have the pop method that doesn't receive anything. We don't need to pass it a parameter. All we need to do is delete the last item in the array. We can simply have a variable, let's say last item, that grabs the last item in our data object. So this is going to just simply be this dot data at index of length minus 1. Remember, we want the index of 1. Even though the length is 2 because we're counting 0, 1, we want the last item in the data. And from here, we can just use the delete keyword in JavaScript and say this dot data at this dot length minus 1, just delete that item. And obviously we need to decrease, so just shorthand here in JavaScript to decrease the length of our data by 1. And then finally we can just return the item that we deleted. So now if I run another command, and by the way, you might see here that I've missed the semicolons in JavaScript. Most of the time, you can get away with not adding semicolons, and some people don't use semicolons at all in JavaScript. Don't get too distracted by that. Sometimes I forget, and it's not really important, at least for our purposes. Let's add a new item to the array. That's going to be the exclamation point. And I'm going to say my or new array dot pop. If I run this, I get an error saying item because this should be last item. There you go. Let's run that again. And we see that it's high u because the exclamation mark has been deleted. If I run pop again, I see that I have length of 1 and only high remaining. Very cool. All right, let's add one last one, and to show you why some operations in arrays are O of n, we're going to add the delete method. And the delete method is going to take an index, which item we want to delete. And in here, we will have to do a const item. So we're going to create a reference to this dot data index, which is the item we want to delete. And how are we going to delete this? Because remember, in an array, we'll have to delete the item, then shift the index of all the other data types by 1. Well, because we want to follow good coding practices, using the idea of single responsibility principle, let's add another function that does this for us, that does the shifting of data for us. I'm going to create a new method, And we do this in JavaScript using the this syntax, shift items. And this method is going to take the index that we received here in the delete. Now, this shift items, we can create it here and say that shift items method. And by the way, I use the words function and methods interchangeably sometimes. Method simply means it's a function within a class. So this shift items will be a method of my array. But it is a function. So this function, which is a method of my array, will have the index parameter passed into it. And this is where we do some fun things. We're going to have to loop through the items. So that's a for loop, which right away should ring the bell and say, ooh, this is an O of n operation. We're going to have an index of 0, or I of 0. Actually, instead of 0, remember, because we want to shift items, not all of them, just wherever the index starts from, we say index. And now I will have to be this.length. So I is less than this.length minus 1. And we're going to increment I by 1 each time through the loop. Within this loop, all we're going to do is say this.data, our data, at each index that we loop through is going to equal this.data at I plus 1. What just happened here? Well, we're saying start at the index that we want to start the delete from and iterate through it all the way until the end. And within this loop, I want you to take each item in the data that we have, and instead of what it had before, I want you to add the data that is right next to it at plus 1. So if we had an array that is 0 and 2, I'm saying from the index of 0 over here, I want you to now instead make 0 equal to 2. So index of I plus 1. So we're shifting the items to the left by 1. So we have shifted here all the items 1 to the left. And because we did that, the index that we gave it for the delete automatically gets replaced because that I is going to get replaced. Now, there's an issue here, right? Because now the very last item in the array, that is this.data at this.length minus 1, which is the last item in the array, will still exist. We've shifted everything over by 1, but we've never touched the very last item because we stopped when I is less than this.length minus 1. So this is still full. So I'm going to comment this out and just show you what happens if we just leave it like this. I'm going to run the new array.delete, and I'm going to remove the pop commands for now. And in the delete, I'm going to say I want to delete the U item. So that's index of 1. If I run this, I get hi, U is deleted, but then I have exclamation mark at index of 1, so the shifting is working. But at index of 2, I still have the exclamation mark because, well, we never deleted it. We've shifted everything once over, but we never touched index of 2. So all we need to do to get rid of that is the delete keyword to delete the last item, and obviously to decrement our length. Because we've just deleted an item, we can do this.length minus minus. If we run this now, hey, look at that. Length of 2, hi, exclamation mark. Let's play a little around to make sure everything is working here. If, let's say, I add a couple more push commands here, and we'll say here are, hi, you are, and then let's say nice. If I run this, I get hi, exclamation mark, are nice. That doesn't make sense. Let's change this to 0 to remove the hi. If I run this, I get you, exclamation mark, are nice. That still doesn't make sense. Let's remove the exclamation mark so that we only have you are nice. I'm going to run the new array, and we can delete index of 1, which is the exclamation mark, and let's see what we get then. If I run this, I get you are nice. Awesome. Now, you might look at this and want to add your own methods. You might want to, let's say, in here, return the last item just as a reference, which is how it works in JavaScript. But I think for now, you have an understanding of how arrays work and how they're implemented underneath the hood. We have simple O of 1 commands, which are really, really nice. But as soon as we have to start shifting indexes and changing things around, we have to loop over things, which makes it O of n, or linear time. I'm going to leave this for you as a playground after this lesson, so you can add your own things, maybe write it in different languages, and explore a little bit more into arrays. But this video is already getting long. I don't want you to get too bored now, so I'll see you in the next video. Bye-bye. Welcome back. I wanted to add a quick video to let you know about a common interview trick. We're going to be doing some array questions after this, but in interviews, you should treat any string questions, like over here, as an array question. You see, strings are simply an array of characters. Most of the time in an interview, when you get a question like reverse a string, what you should be thinking is to convert this into an array, do some sort of a loop on it or an operation using something like a split method in JavaScript, and then returning it as a string after you've finished the operations with them. So that is a very common interview question where you're manipulating strings. Just keep that in mind, and we'll actually demonstrate this in the next video when we do a very common interview question. I'll see you in that one. Bye-bye. Welcome back. Let's get into some fun interview questions. We're going to start off with a very, very common one, and it shouldn't be too complicated to start us off. The interviewer asks you, can you create a function that reverses a string? So if you passed into this function right here, hi, my name is Andre, it should return this gibberish that is, oh, and I forgot M here, this gibberish that is, well, backwards. It's just simply reversing a string. Now, I want you to go ahead and try this in your own REPL.it or whichever text editor you use and see if you can think through the problem, use what you know about arrays to solve this. Now, keep in mind, when it comes to questions like these, there are many ways to do things. As programmers, we know this, right? There are so many ways to solve a problem. And depending on our style, our knowledge, and time, we're going to come up with different solutions. So if your answer is different than mine, well, that's not the worst thing. What you want to be able to do is to think through a problem and understand why you made those decisions. So go ahead, reverse a string, and I'll see you in the solution video. Bye-bye. Welcome back. Now, I'm not going to go over all of our steps that we used in the section where we talked about how to solve problems and how to talk through your problems in front of an interviewer. And we even watched that Google video of all the things you need to do. Because that's going to take way too long of a time, I'm going to speed things up and just talk about the key points of how you would solve this problem. Well, in order to reverse a string, the first thing we want to do is some sort of a check of our input. We can't just assume that we're going to always receive a string. What if somebody calls the reverse function with, well, undefined, or with a number? What happens then? And a good thing to always start off with is to check the input. In my case, I'm going to do a simple check. Let's say that if there's no string, so that is undefined, or perhaps that the string.length is less than 2, that means, well, if string.length is less than 2, that means I'm just receiving one letter or no letters, in which case we don't really need to do any operations. It's already kind of reversed. And we can add different input validation here, such as using the type of keyword in JavaScript to check if it's a string type. But that's something you can just do on your own. Actually, let's implement it since we're here anyway, just to show you. So I can say type of string if it doesn't equal string. Type of str, which is the parameter we receive, doesn't equal the string type. Well, in that case, we can just return, that's not good. Otherwise, let's do some operation. To reverse the string, well, let's think about this. We want to convert it into an array. So I'm going to create a backwards array. And this is what we're going to return from the function. I'm going to return the array that is reversed, but we want to return a string, right? It reverses a string. This should return a string. Even though we're going to convert whatever we receive into an array, at the end, we want to turn it back into a string. So in JavaScript, we can do the toString method or the join method. And we just say join all the items in the array. Now in here, we're going to grab the length of the array or the string because we're going to be using it a lot and we don't want to have repeated code. So I'm going to say length minus 1 is how many items we have in the string. Or maybe we should name this items number. Or actually, total items. That's a better name. Now, these total items, so we're going to loop through our string. We'll say let I equals to the total items. So I is going to equal however many characters we have in our string. And we're going to keep going until I is equals to 0. And all we're going to do, because we want to go from back to front, we're going to decrement this. So we're going to go from the length of the string all the way back. So we're going to start off with I, E, R, D, and A, and insert those into an array that we've created, the backwards array, one by one. So in this loop, all we're going to do is say backwards dot push each item that we're going to create. So str I. And I know what you're thinking. Whoa. Why didn't we just convert the string into an array? You told me all about converting strings into an array, and we didn't really do that. And JavaScript actually has the str.split, or we can run the split command to split things into an array. But with JavaScript, we can actually just use strings as arrays and access each property like this with bracket notation so that they essentially are arrays. So we don't have to run any split commands. This also works. And all we're doing is we're going backwards one by one and pushing each item of our given string into our array. So if I console log here before we run the join command, the backwards array, and I run reverse, and let's reverse this string. Let's run this. Oh, and you may have noticed that this length didn't really come from anywhere. It should be total items. So this is the total items. This is the problem with live coding. I tried to show that everybody makes mistakes, even myself.